Hey there everyone, Ramesh here, back again with another new brand full course. The course name is Java 8 Complete Tutorial. Well, this Java 8 tutorial is going to be a complete reference to important Java 8 new features. Okay, and this tutorial is going to be a full 4 hours course, guys. In this course you will learn all important Java 8 new features with lots of examples. So let's take a look into what you will learn in this course. We will learn about Lambda expressions first. Well, as we know that Lambda expressions facilitates a functional programming in Java, right? So first we're going to see how we can use a Lambda expressions to write a code in a functional programming in Java. Okay. Next we'll see how to define the functional interfaces, and we'll also see how to use commonly used predefined functional interfaces. Well, Java 8 basically provides a lot of predefined functional interfaces. Okay, and in this course we will see some of the some of the commonly used predefined functional interfaces with an example. And next we'll see one more Java 8 important feature, that is method references and types of method references. And next we'll see how to use optional class to avoid the null checks as well as null pointer exceptions. And next we'll see how to create a default and static methods in a interfaces. Next we'll see stream APIs. Well, we're gonna learn a lot about stream API in this course, guys. We'll see how to filter, map, sort, find, collect using stream APIs. Alright, in this course we'll learn all these Java 8 important features with lots of examples. Alright, without further ado, let's go ahead and let's kickstart this course. Well, let's first take a look into what is Lambda expressions and what is the main use of Lambda expressions in Java. Well, Lambda expressions were introduced in Java 8, and Lambda expressions facilitates a functional programming in Java. Alright. Well, what is Lambda expressions? Well, Lambda expression is an anonymous function. It means it is a function without name and does not belong to any class or object. Okay, Lambda expression is nothing but anonymous function. It means it don't have any name and it does not belong to any class or object. Okay, and the main use of Lambda expression is to implement functional interfaces. Well, before deep dive into Lambda expressions, first let's quickly take a look into functional interfaces, because we are going to use Lambda expression to implement functional interfaces, right? That's why you first need to understand what is functional interfaces. Then only you can able to understand more about Lambda expressions. Alright, so Lambda expression is basically used to implement functional interfaces. So let's quickly take a look into what is functional interfaces first, and then we'll come back to Lambda expressions. Well, functional interfaces were introduced in Java 8. An interface that contains exactly one abstract method is known as functional interface. Alright, so functional interface is an interface that contains exactly one abstract method. For instance, look at here the code snippet. My functional interface is an interface and it contains exactly one method, that is execute method. And as we know that whenever we define a method in an interface, by default it is abstract, right? And we no need to mention abstract keyword in a method. Alright, so just remember, functional interface is an interface that contains exactly one abstract method. Abstract method means a method we don't have any implementation. Okay, so in order to provide implementation for this method, you have to create a class and then you need to implement this interface, and then you need to override this method, and then you need to provide the implementation for this method. Alright, so just remember, functional interface is interface that contains exactly one abstract method. Well, functional interface can have any number of default static methods but can contain only one abstract method. For example, consider the code snippet over here. My functional interface is a functional interface. It contains default and static methods which has the implementation, and it can contain only one abstract method, that is execute method. Alright, so functional interface is an interface. It contains only one abstract method, but it can contain any number of default or static methods. Alright, and default and static methods are introduced in Java 8, and you can provide implementation for default and static methods. Alright, but abstract method don't have any implementation. Alright, so now we understood that functional interface is interface. It contains only one abstract method and it can contain any number of default and static methods. Alright, now let's go back to our Lambda expression and then we'll deep dive into the Lambda expressions. Well, sometimes beginners may confuse with the Lambda expression and methods. So let's go ahead and let's see the difference between Lambda expression and method. Alright, so that you can able to understand a Lambda expression better. Well, method is always belongs to class or object in Java, whereas Lambda does not belongs to any class or object. Okay, so whenever you create a method in Java, you should have to create that method in a class, right? But Lambda does not belong to any class or object. It should be isolation to the class or object. Okay, and you can able to see method has these parts, like method has a name, parameter list, body and return type. For example, look at here the addition method over here. Addition is the method name, int is the return type, int a comma int b is the parameter list, and return a plus b is the method body. So this is how we create a method in Java, and these are different parts of the method. Okay, now let's see how Lambda expression looks like and different parts of the Lambda expression. Well, Lambda expression has no name. It means Lambda expression is an anonymous function, right? So we no need to have to provide a name to the Lambda expression. Lambda expression has a parameter list. Lambda expression has a body. Okay, and no need to mention the return type. Well, you don't need to mention the return type in the Lambda expression because Java 8 plus compiler is infer the return type by checking the code. Alright, so in Lambda expression we don't have to mention the return type because Java 8 compiler is smart enough to identify the return type of the expression. Okay, we'll see an example how Java compiler can identify the return type. Okay, so if you can see the code snippet over here, so this is how the Lambda expression looks like. Alright, so this is the parameter list of the Lambda expression and this is the arrow. It will basically link the parameter list with the body, and this is basically a Lambda expression body. Lambda expression body can contain a single statement or multiple statements. Alright, we'll understand more about Lambda expression in a example section. Now let's take a look into Lambda expression syntax. Well, Lambda expression basically contains these three parts. First part is Lambda input parameters. Second part is arrow. So this will denoting Lambda. Third part is Lambda body. Okay, just remember this syntax because whenever we write the Lambda expression, we use this syntax. Okay, so first part is Lambda input parameters. Second part is arrow. Third part is Lambda body. Alright, now we pretty much understood overview of Lambda expression. Now let's go ahead and let's deep dive into Lambda expressions by creating the examples. Well, let's open the IntelliJ IDEA and let's go to new project option over here and go ahead and click on it. And then here choose Java and then choose project SDK. So whatever the JDK you have installed in your machine, that you can go ahead and select from here. So I have installed Java JDK 16, so I'm going to choose 16 over here and then click on next, and here you need to provide the project name. So I'm going to provide project name something like Java Lambda expressions, and you need to choose the project location over here. In my case, I'm going to locate this project in a downloads folder. So go ahead and click on finish. Alright, and let's go and let's create one simple package. So go to src folder, right click new and then choose package. Let's go package name something like com.java.lambda, hit enter, and within this package let's create a class and let's name it as something like Lambda example. Okay, great. Now let's go and let's first see how to write a code using traditional way, and then later we'll convert the traditional way into functional programming using Lambda expression. Okay, first we'll write a code using traditional way. Well, let's go and let's create a SAP interface and let's provide a few implementations for SAP interface. Well, here I'm going to create an interface called SAP. Alright, well, within a SAP interface, let's define a method called draw. So we're going to basically draw a SAP. Okay, And whenever we define a method in an interface, by default it is public and abstract, right? So we don't have to again add a public abstract keyword to this method. Alright, now let's go and let's create a few implementations for this interface. So let's first have a rectangular implementation. Okay, let's create a class rectangular which implements shape interface, and just go ahead and mouse over on this rectangle and you can see implement method. So just go ahead and click on it and choose draw method here and then click on OK. Alright, now we have overridden draw method within this rectangle class. Let's go and let's provide implementation for this draw method. So to keep it simple, I am going to just provide one sysout over here, and then I am going to write a statement something like rectangle class draw method, something like this. Now we have created a rectangular implementation for shape interface. Similarly, let's go and let's implement square and circle. Okay, so just create a class, let's name it as a square which implements shape. Alright, and just mouse over on this square class and click on implement methods, click on draw, click on OK, and just put one sysout, and let's call it as square class draw method. Alright, and similarly let's create one more class implementation that is for circle. Now implements shape interface, and let's override this method and provide the implementation. Okay, pretty simple. Now what we have done, basically we have created rectangle, square, circle. So these are the classes which implements shape interface. Okay, so this is how we write the code in a traditional way, and this is basically a polymorphism. Okay, method overriding. So basically we are overridden the method and we have provided the implementation in a class. Okay, so this is basically a polymorphism concept. Okay, now let's see how we can use a lambda expression to convert this object oriented polymorphism concept into functional programming. Okay, so basically we have written a lot of code over here. Okay, and we can use a lambda expression to reduce a lot of code. Well, you can closely observe this interface, that is shape interface. So this is basically a functional interface because it contains only one abstract method, right? And we have provided a classes which implements this interface. So now what we can do is we can replace all these class implementations with the lambda expression. Okay, so I'm going to basically show you how we can use a lambda expression to reduce a lot of boilerplate code over here. Okay, we basically convert this object oriented program into functional program using lambda expression. Okay, it's pretty simple guys, just follow the steps that I'm going to show here right away. So first what we're going to do is we're going to copy this method and we convert this method into lambda expression. Okay, so I'm going to show you my personal tip how I convert methods into lambda expression. Okay, just copy this method and go to this public class over here and then simply create a main method, and within main method simply paste this method. Well, one more very important point is lambda expression can be assigned as a value to the reference variable. For example, in Java we basically create a variable like this, right? For example, string str equal to hello. Okay, so this is how we basically assign a string value to the variable of type string. Well, basically we need to assign a lambda expression as a value to the reference variable, and we have to use a reference variable of type functional interface. In our case, shape is a functional interface, right? So let's go ahead and let's have a shape reference variable here, and let's call it as a rectangle. Okay, and get rid of this at override annotation. All right, now we haven't completed our lambda expression yet. We need to remove some parts from this code. Well, here public does not make sense in a lambda expression, so we have to remove this public because public makes sense in case of method and variables in a class, but lambda expression is not belong to any class or object. So get rid of this public from here. And as we know that lambda expression is an anonymous function, you don't have any name, so get rid of this name. Okay, and yeah, well, you can see the return type void over here. Well, we can also get rid of this void return type from here, because Java 8 plus compiler will automatically infer the return type of the code. For example, what Java compiler does, like it will look into this abstract method and it will look into the return type of this abstract method basically, and the return type is void, right? So by looking into the return type of the abstract method here, Java compiler will infer the return type of this Lambda expression, right? So we don't need to again mention the return type over here. All right, so let's get rid of this return type from over here. Now in order to complete this Lambda expression, we need to put a Lambda symbol between this, open and close parenthesis and this open and close curly braces. So let me put a Lambda symbol, that is arrow symbol. So arrow symbol basically link this parameter list into method body, and in case of Lambda expression you need to put a semicolon at the end of this Lambda expression. Okay, now this is your Lambda expression. It's pretty simple, right? Again, you can make this simpler. For example, let's say in a Lambda expression body, if you have only one statement, then you can also get rid of this open and close curly braces. Okay, so let me remove this, and if you can see here, now the Lambda expression looks neat and cleaner, right? So this is how basically we write the Lambda expression to implement a functional interface. So basically what we have done, we have assigned this Lambda expression as a value to the reference variable of type shape. So shape is a functional interface. Now what we're going to do is we're going to call a draw method by using this reference variable. So simply call draw method over here. Okay, pretty simple. Now let's run the program and let's see how this code works. Well, if you can see here, rectangle class draw method, it means that the Lambda expression that we have written to implement shape functional interface is working as expected. Alright, so this is how basically we write the Lambda expression to implement a functional interface. Well, if you look at the code of rectangle class implementation, we need to write a lot of code, right? And if you look at the again Lambda expression, in 2 lines of code, we have done the job of this much of code. Okay, so this is the traditional way how we write the code to implement the interface, and we override the method and provide the implementation, right? So now what we have done, basically we have converted this object oriented programming into a functional programming using Lambda expression. All right, so in order to have a hands-on experience, let's write the Lambda expression for square and circle as well. So before that, let me remove this code. Okay, now let's write the Lambda expression for square and circle to reduce the boilerplate code. Well, simply copy this draw method from square class and go to main method. Within a main method, paste it over here and just get rid of this annotation. All right, and just assign this block of code to the reference variable of type shape. Shape is here a functional interface. Let's say the reference variable name something like square, and this should be a typo here. All right, now let's remove the unnecessary parts. Well, public does not make sense here, so just remove public. And also the Lambda expression is an anonymous function. It means Lambda expression don't have name, so get rid of this draw name here. And also we can remove the return type, because Java 8 compiler will automatically infer the return type by looking into the code. So get rid of the return type as well. All right, and let's put a symbol arrow here. All right, and let's also put the semicolon to complete this Lambda expression. Okay, now this becomes our Lambda expression. And if you can observe this Lambda expression over here, this Lambda expression body contains only one statement. We can also remove this open and close curly braces. Okay, let me get rid of this open and close curly braces from over here, and then we can simply call square dot draw method over here. That's it, pretty simple. Now let me run the program and let's see how it works. And there we go, it is working as expected, isn't it? Now let's go and let's write the Lambda expression for circle implementation. Okay, so as usual, just copy this method, go to main method and paste it over here, get rid of this annotation, and then let's assign this block of code to the functional interface and let's call it as circle. Okay, and let's remove the unnecessary parts. Public is not required, name is not required, return type is not required. Alright, and just put the arrow symbol and put the semicolon at the end of this lambda expression. And this lambda expression body contains only one statement, so get rid of this open and close curly braces as well. Perfect. Now circle.draw. Okay, let's run the program and let's see how this works. And there we go, it is working as expected, right? So this is my personal tip how I convert basically a method into lambda expression. So I hope you found this technique useful. Now let's go and let's see how to pass a lambda expression as a method parameter. Well, in order to demonstrate that, I am going to create a method over here. Let's say private static void, and let's give method name as a print and just pass a method parameter of type shape here. Alright, and then simply call shape.draw method. Okay, now let's go and let's use this print method and let's pass a lambda expression as a method parameter. Well, go to the main method here and go at the bottom, and here simply call print method. And if you can see here, print method expect implementation of shape interface, right? And here we have used lambda expression to implement shape interface. So just go ahead and pass one of the lambda expression here. So here I am going to pass a rectangle. Okay, so this is how basically we pass a lambda expression to the method. Okay, if you can see here, we have stored this lambda expression is in a variable of type functional interface, that is shape, and we are passing this variable as a method parameter here. Okay, and we can simply comment out this rectangle dot draw method because this call we have made within this method. Right, similarly simply call print method and then pass square. So this is how we pass a lambda expression to the method, and we can simply comment out this code. And similarly let's pass a circle lambda expression and simply comment out this code. Now let's run the program and let's see how this works. And there we go, it is working as expected. Alright, so this is how basically we pass a lambda expression to the method. And if you can see here, we can directly pass this lambda expression here, for example like this. Okay, instead of assigning a lambda expression to a variable, we can directly pass a lambda expression to the method, something like this. Similarly, let's do it for square and circle. Let me copy this and paste it here, and let's get rid of this code here. Alright, this looks good, right? So this is how basically we pass a lambda expression as a method parameter. Okay, so basically here we are passing a behavior to the method. Okay, we are passing lambda expression as a behavior to the method. Okay, this is called basically a functional programming. Okay, so these are the very important things you have to know in order to write the functional programming in Java. Now let's go and let's write one more lambda expression example to see how we can pass the parameters to the lambda expression. Alright, great. Go to the package and right click, new and choose Java class, and here let's give class name as lambda parameter, something like this. And let's create one functional interface, let's say addable. Alright, and just create one method, let's say addition int a comma int b. Okay, so this is nothing but a abstract method. Alright, perfect. Well, first we're going to see how we can use a traditional way to implement this functional interface, and then we'll convert a traditional way into functional programming using lambda expression. Alright, just create a class and let's say addable impl is a class name. It implements addable interface. Now let's go ahead and let's override this addition method in this class, and let's provide the implementation for this addition method. Well, if we can mouse over on this class, you will get an option to implement the method. So go ahead and click on implement methods over here and choose addition, and then click on OK. And here basically we are going to add these two numbers, right? So just write the logic here, that is a plus b. Okay, pretty simple. Now we have created a class which implements this functional interface, and we have basically overridden this method and provided the implementation for this method. Well, this is how we write the code using traditional way. Now let's go and let's see how we can convert this traditional way into functional programming using Lambda expression. So go to Lambda parameters class. Within this class, let's have a main method over here. Okay, and in order to convert this method into Lambda expression, simply copy this method and paste it within a main method and get rid of this annotation, and then simply assign this block of code to the functional interface. Okay, and let's call it as addition, and let's remove the unnecessary parts. Public is not required and method name is not required because a Lambda expression is an anonymous function. It don't have name, so get rid of this addition name. And also this int return type is not required because Java compiler will automatically infer the return type by looking into the return type of the abstract method. So in this case the return type is int, so compiler will automatically recognize that the return type should be int. So get rid of this return type from here. Alright, and now let's put arrow symbol and also put the semicolon at the end of this Lambda expression. So this becomes our Lambda expression. Okay, now let's go and let's also simplify this Lambda expression even more. Well, if you can see the Lambda expression body over here, it contains only one statement. So also get rid of this open and close curly braces. Well, let me remove this. And if you can see here, if the Lambda expression body contains only one statement, so we can also get rid of this return keyword from here. Okay, now this Lambda expression becomes a neat and concise, right? Now let's go ahead and let's call the method here, that is addition method, and just pass 10, 20. Perfect. Well, if you can closely observe this Lambda expression over here, we are using a parameter list, that is int a, int b. So this is how basically we pass the parameters in a Lambda expression. Okay, and these parameters we are using in the Lambda expression body, and this arrow symbol basically link the parameter list to the body of the Lambda expression. Okay, so this is the best example to see how to write a Lambda expression using parameter list. Okay, and if you can see the type in a parameter list, for example, a is a variable, it has a type int, b is a variable, it has a type int. So we can also remove this type here. Okay, for example, if I remove this, then Java compiler will basically automatically infer the type of these parameters. Okay, we don't have to again mention the type for these parameters because Java compiler is smart enough to identify the type of these parameters by looking into the method parameters. For example, addable functional interface has an addition method, right? And this addition method we are implementing here by using Lambda expression, and Java compiler will basically look into the type of these variables here. So a has a type int, b has a type int, right? So Java compiler will basically look into this type of the parameters. All right, so that's why we can also remove the type from here. Okay, so I hope you understood. Now let's go and let's print the result of this method. So here what I will do, I will say int result equal to, and then I will put this out here and then simply print the result. Okay, now let's go and let's run the program and let's see how this works. And there we go, addition of 10 plus 20 is 30, right? So this is how basically we write the Lambda expression which has a parameters. Okay, now let's see how to write a Lambda expression. It contains a multiple statements. Alright, we'll take this example itself. So here what I'm going to do is I'm going to just comment out this code over here, and I'm going to rewrite the Lambda expression for this method. So I'm going to copy here, paste it, and get rid of this annotation and just assign this block of code to the functional interface. Alright, and just get rid of this these unnecessary parts and put arrow mark here and put the semicolon at the end of this lambda expression. Okay, now what we're gonna do is we're gonna write the multiple statements here. So basically here what I will do, I will say int c equal to a plus b. Alright, and then I will simply return c. Okay, so this is how basically we write the multiple statements in a lambda body. Okay, now if you can see, lambda body contains two statements. Now let's go and let's create one more lambda expression example to implement runnable interface. Well, runnable interface is basically a functional interface, and we can use a lambda expression to implement a runnable interface. Well, go to the package, right click on the package, new, and then choose Java class, and let's give class name as something like runnable lambda example and hit enter. Now first we'll see how to write a code using traditional way, and then later we'll see how to write the same code using lambda expression. So here we'll create a class which implements runnable interface. Let's say thread demo class which implements a runnable interface, and then simply override the run method over here. Just mouse over, click on implement methods, choose run method, and there we go. And to keep it simple, within the run method we'll put a sysout and just print a run method called something like this. Okay, now go to the runnable lambda example class and then create a main method, and within a main method we are going to create an instance of thread class. So let's create object of thread here and then pass object of thread demo. Okay, and then simply start the thread here. Okay, so this is how traditionally we create a thread object. Okay, we create a class, implements runnable interface, and then we override the run method and we provide the implementation for run method, and we create a thread instance here and we pass the object of thread demo class, and then we start the thread. Okay, so this is how we create the thread using traditional way. Now let's go and let's see how to use a lambda expression to implement a runnable interface, and then we'll create a thread object. Okay, well, if we can go inside runnable interface source code, you can able to see runnable is a functional interface because runnable contains only one abstract method, that is run method. And if you can see, runnable interface is annotated with add functional interface annotation. It means runnable is a functional interface, and we can use a lambda expression to implement a runnable interface. Alright, so let's go back to our class, and here we're going to use a lambda expression to implement a runnable interface. Let's use a runnable functional interface reference variable to assign the lambda expression. So this is the syntax of the lambda expression, right? And simply put one sysout within a lambda expression body and just call it as run method called using lambda, something like this. Alright, and then we need to create instance of thread over here. Thread, let's say lambda equal to new thread, and then pass runnable, and then simply start the thread. Perfect. So this is how basically we implement a runnable functional interface using lambda expression, and then we create a thread object, and then we pass a lambda expression implementation as a parameter to this constructor, and then we start the thread. Okay, so let me run the program and let me show you, and there we go. So this is working as expected. Well, we can simplify this lambda expression even more. If you can see here, lambda expression body contains only one statement, so we can get rid of this open and close curly braces over here. All right, perfect. And if you can see here, we can simply pass this lambda expression itself as a parameter to the constructor. For instance, I'm going to pass here, and I'm going to get rid of this statement. Okay, so this is how we can pass a lambda expression as a parameter to the constructor as well. If I run the program, it should work, and there we go. All right, so this is how basically we use a lambda expression to implement a runnable interface, and we pass that lambda expression to the thread object, and then we start the thread. All right, I hope you understood how to use a lambda expression to implement a runnable interface, and how to create a thread, and how to pass a lambda expression. All right, great. All right guys, I hope you pretty much understood how to create a lambda expressions in a Java. You will learn what is functional interface with an example, and then you will learn how to define a functional interface using add functional interface annotation. Well, basically you will learn how to define your own functional interface using add functional interface annotation. And then next you will learn how to use a lambda expression to implement functional interface. And then we'll also see some of the predefined functional interfaces with examples. Well, Java 8 basically provides a lot of predefined functional interfaces. Okay, and we'll see a couple of predefined functional interfaces with an example. Okay, next we'll see how to use a runnable functional interface with an example. Well, functional interface were introduced in Java 8. Alright, and functional interface is nothing but an interface that contains exactly one abstract method is known as functional interface. Well, consider the code snippet here. My functional interface is an interface and it contains exactly one abstract method, that is execute method. Well, as we know that whenever we define a method in an interface, by default that method is abstract, right? So we don't have to again mention the abstract keyword in a method. Alright, so just remember, a functional interface is an interface that contains exactly one abstract method. Alright, well, functional interface can have any number of default and static methods but can contain only one abstract method. Well, consider the code snippet again over here. Interface, my functional interface is a functional interface. It contains default and static methods, but it contains exactly one abstract method, that is execute method. Alright, so this is a valid functional interface. Alright, so functional interface is nothing but an interface that contains any number of static and default methods but contains exactly one abstract method. Well, we can use a Java 8 provided add functional interface annotation to mark an interface as a functional interface. Well, let's go ahead, let's create one example. Well, here I am going to create one interface. Let's call it as my functional interface. Okay, and in order to make this interface as a functional interface, we have to define one abstract method. For example, let's say void print something like this, and I'm going to pass a parameter something like message. Okay, so this is nothing but our functional interface, because functional interface is an interface, it contains exactly one abstract method. Alright, perfect. Now in order to mark this interface as a functional interface, we can use add functional interface annotation from java.lang package. Well, basically this annotation we are introduced in Java 8 to mark the interface as a functional interface. Well, if you know that this interface is going to be a functional interface, then you can ignore this annotation. Alright, otherwise if you want to explicitly mark this interface as a functional interface, then you can go ahead and use add functional interface annotation. And if you try to add another method, for example, let's say void display something like this, then this will give a compile time error, because you are here using add functional interface annotation to mark this interface as a functional interface, and functional interface is nothing but an interface, it contains exactly one abstract method, right? But here we are trying to add one more abstract method. Okay, we are totally added two abstract methods. That's why it is giving a compile time error here, because functional interface contains exactly one abstract method, right? So let's go and let's remove this method, and now this is a valid functional interface because it contains exactly one abstract method. Well, functional interface can contain any number of default and static methods. For instance, let's say default void m1 is the method name, and default method contains a body, right? Let me put one sys out over here, and let's say default method. And functional interface can contain any number of static methods, right? Static void, let's say m2, and let's put one sys out, and let's say static method. All right, perfect. Well, by looking into this functional interface, you can easily understand that functional interface is an interface. It can contain any number of default and static methods, but it should contain only one abstract method. And this is how we basically define our own functional interface. All right, great. Well, so far we have seen what is functional interface and how to define our own functional interface using add functional interface annotation. Now let's go and let's see how to use a Lambda expression to implement functional interface. Well, basically we are going to create a SAP functional interface, and then we'll see how to use a Lambda expression to implement SAP functional interface. Well, let me adhere to the IntelliJ idea, and let me create a class over here, and let's say Lambda example, and here I'm going to quickly create a functional interface. So just remember, the main use of Lambda expression is to implement the functional interface. So let's go and let's first define the functional interface over here. Let's say the functional interface name is SAP, and let's create one abstract method, let's say draw. And here we are not mentioning the abstract keyword because by default the method is abstract in a interface. And let's first see the traditional way to implement this functional interface. So let's create a class, and let's give a class name as rectangle. So rectangle is a SAP, right? So let's implement SAP interface over here, and let's override the method, that is draw method, and let's provide the implementation. Well, to keep it simple, let me put one sys out over here, and let me call it as rectangle draw method. All right, perfect. So this is how basically we write a code using traditional way to implement a interface, right? So this is nothing but a method overriding. Okay, this is basically oops polymorphism concept. Now let's go and let's convert this oops concept, that is polymorphism concept, into functional programming using Lambda expression. All right, so within this class let's create a main method, and now let's convert this code into a Lambda expression. So pretty simple. So let me simply copy this method and paste it here. So this is my personal technique how I convert basically a method into Lambda expression. So it is very useful, so just follow this step. So we'll get rid of this annotation, and we basically in Java we can assign a block of code to the variable using Lambda expression. So here what I'm going to do is I'm going to assign this block of code to the interface called SAP interface. So SAP is basically a functional interface, right? And we can assign a Lambda expression to the functional interface variable. So here what I'm going to do is I'm going to assign this block of code to the functional interface. Now let's go ahead and let's remove the unnecessary parts from this code to form a Lambda expression. Well, here is a public. Well, public access modifier does not make sense with respect to the Lambda expression, because Lambda expression is not belong to any class or object, right? This public access modifier makes sense with respect to a method or instance variable, right? So get rid of this access modifier. And as we know that Lambda expression is an anonymous function, so let's go ahead and let's remove this method name, because Lambda expression is an anonymous function and it don't have any name, right? So let's get rid of this name. Well, what remains? Void. So void is basically a return type, isn't it? And in a Lambda expression we don't have to mention the return type, because Java compiler will automatically infer the return type by looking into this method in a functional interface, right? So this abstract method has a return type void. So here we don't have to mention the void in a Lambda expression, because Java compiler will automatically infer the return type of this Lambda expression. All right, so let's get rid of this return type. Okay, now in order to complete this Lambda expression we have to provide a arrow symbol over here. Okay, and we need to provide a semicolon at the end of this Lambda expression. All right, and this is your Lambda expression. It's pretty simple, right? So I hope you understood how to convert a method into Lambda expression. And here you can see this Lambda expression body contains exactly one statement. So we can also simplify this a bit. So here I am going to simply remove open and close curly braces, and this is how your lambda expression looks like. And in order to call this functional interface, we are going to call here draw method. Okay, now I am going to run this program and let's see how it works. And there we go, rectangle draw method. Okay, it means that we have successfully written a lambda expression for this shape functional interface, and we can simply get rid of this code. Okay, and if you can compare the code over here, we have written only 2 lines of code to implement this functional interface, but in a traditional way we need to write this much of code to implement this functional interface. But here lambda expression reduces a lot of code here, isn't it? So this is how basically we use a lambda expression to implement the functional interface. And just remember, lambda expression is a anonymous function. It don't have any name and it does not belong to any class or a object. Well, so far we have seen what is functional interface and how to define our own functional interface using add functional interface annotation, and we have also seen how to use a lambda expression to implement functional interface. Now let's go and let's check out some of the Java 8 provided predefined functional interfaces, and we will also see how to use some of the predefined functional interfaces with an example. Well, let's head over to the browser first, and in a new tab just type java.util.function. Alright, so in Java 8 basically this package is introduced, that is java.util.function package. Well, functional interfaces provides a target types for lambda expressions and method references. So basically we use a lambda expression to implement a functional interfaces, and we assign a lambda expression as a value to the reference variable, right? Reference variable in this case a functional interfaces. Alright, so basically we use a functional interfaces as a target types for lambda expressions and method references. Well, here you can see a list of functional interfaces. So these are basically predefined functional interfaces were introduced in Java 8. And now what we're going to do is we're going to see some of the frequently used predefined functional interfaces with an example. Okay, so first we're going to take a look into function interface. So let me open in a new tab. Well, function interface is a functional interface, and you can see it is a generic basically, and it takes 2 parameters. This is the type of the input to the function, and this is the type of the result of the function. And basically this function interface has a method called apply method basically, and it is an abstract method, and we need to provide implementation for abstract method. Okay, so you can see function interface basically represents a function that accepts one argument and produces the result. Alright, so let's go and let's see the example of this functional interface so that you will understand better. Well, let's go to the IntelliJ IDEA and let's create a new package. Let's call it as functional and hit enter, and within a functional package let's create a new class and let's call it as function demo, and then within this class let's create a main method. Now what we're going to do is we're going to see how to use a functional interface using traditional way, and then we'll see how to use lambda expression to implement functional interface. So let's create a class over here, and let's say function impl is a class name. It implements function interface, and if you can see here function interface is from java.util.function package. So let's choose this and let's pass 2 parameters because function is a functional interface and it is annotated with add functional interface annotation, right? And this functional interface represents a function that accepts one argument and produces the result. Alright, and it has an abstract method called apply. It takes one argument and it produces the result. Okay, it basically takes our input parameter and it will return the output parameter. So let's see first a traditional way. And here function is the generic interface, so we need to pass 2 parameters. Let's say string is the first parameter and it is the input, and second parameter let's pass the integer. Well, this example is basically take the string as an input and return the length of the input string. Alright, now let's go and let's implement the abstract method. So just mouse over it. implement functions and choose apply, hit OK, and here what you want to do is we're going to basically return the length of the string. Okay, great. Now go to the main method, and here let's create an object of this class and let's call this apply method. So here I'm going to simply create an object of functional IMPL class, and then here I'm going to call apply method, and I'm going to simply pass a string as a Ramesh. Okay, now we want to print the result of this apply method, right? So here what I'm going to do is I'm going to use sysout and simply pass this method call. Okay, this will print the result of this apply method. So let me run the program and let me show you the result, and there we go. The length of the string Ramesh is 6, right? So this is how basically we use a traditional way to implement a function interface and provide the implementation for this apply abstract method. Okay, so this is a traditional way, and if you can see, we need to write a lot of code in order to implement this interface and in order to override this single method and provide the implementation, right? We need to write a lot of code basically. Now let's go and let's see how to use a Lambda expression to implement this function interface. Okay, it's pretty simple. Now what I want to do is I want to simply comment out this code, and I am going to copy this function and paste it here, and let's convert this function into Lambda expression. So first of all, get rid of this annotation and assign this function to the functional interface. In our case, function is a functional interface, right? So let me simply copy this. Alright, and let's have a variable name, something like function. Okay, now let's get rid of some of the unnecessary parts. So public is not required, and also the name is not required because Lambda expression is an anonymous function. We don't have to provide a name to the Lambda expression, and also we no need to provide a return type over here, and here we need to provide the arrow symbol, and then we provide a semicolon at the end of the Lambda expression. So this is your Lambda expression basically. Now we can simplify this Lambda expression even more. For example, if the Lambda expression body contains only one statement, then we can also remove the open and close curly braces. So simply let me remove this, and if you can see here, return keyword. So we can also remove this return keyword because Java compiler is smart enough to identify the return type of the function. So let's remove this return from here. Now this is the Lambda expression. Okay, this is a simplified Lambda expression. Now let's go and let's call the apply method, and let's pass the input as a Ramesh. Okay, and also put this statement in a system out.println so that we can print the result. Now let's run the program and let's see the output, and there we go. Okay, so the Lambda expression that we have created to implement function interface is working as expected. Well, if you can see the lines of code over here, without Lambda expression we need to write a lot of code here. For example, we need to create a class which implements this interface, and we need to override the method, and we need to provide the implementation, and again we need to create an instance of this class, and then we need to call its method, right? So we need to write basically a lot of code. But by using Lambda expression, if you look at here, only we need 2 lines of code. Okay, so using Lambda expression we have written only 2 lines of code. So this 2 lines of code have done the job of all this much of code. Okay, so basically Lambda expression, it simplifies a lot, right? It reduces a lot of code here. All right, so it is always recommended whenever you have functional interface, then try to use Lambda expression. Okay, now we have seen how to use functional interface. So whenever you have a requirement to take an input and return the output, then you can go ahead and use functional interface. All right, great. Now let's take a look into consumer functional interface. Well, consumer functional interface, it is a generic interface, and it takes a single type here, and this type is basically input to the operation. All right, and consumer functional interface basically represents an operation that accepts a single input argument and returns a no result. Okay, and this consumer functional interface has a abstract method called accept method. So we are going to basically implement this accept method, and this accept method takes a single input argument and it does not return anything. Okay, so whenever you have a requirement to take the input and just print that input, then you can go ahead and use consumer functional interface. So basically consumer functional interface will consume the input argument, it won't return anything. Okay, so let's see the example of it. Well, right click on the package, new, and then choose Java class. Let's give class name as consumer demo, hit enter. Now first we're going to see the traditional way how we can implement the consumer functional interface, and then we'll see how we can use a Lambda expression to implement the consumer functional interface. So let's create a class and let's call it as consumer. IMPL is a class name, it implements consumer functional interface. And look at here, consumer functional interface is from java.util.function package, and it is a generic interface, so we have to pass the type. Alright, so here we want to pass the type as a string, and then let's implement its method. So if you can go inside consumer functional interface, it has a method called accept. Okay, it basically accepts the input and it does not return anything. Alright, now in this example what we're going to do is we're going to accept the string and we simply print that string to the console. Alright, now let's go and let's implement the accept method over here, and let's put the sys out and let's print this string, that is yes. So let me rename this, let's call it as input. Alright, now we have used a class to implement consumer functional interface. Now go inside consumer demo class and let's create a main method. Within a main method, let's create an object of consumer IMPL class. So here I am going to simply say consumer equal to new consumer IMPL, and let's call the accept method, and let's pass the string, let's say Ramesh, or let's say hello world. Alright, perfect. Now let's run the program and let's see how this works. And if you can see here, hello world. Alright, so this is how basically we implement a consumer functional interface using traditional way. Okay, so we create a class which implements consumer interface, and we simply override its method and we provide the implementation for its method, and then we create an object of this class and then we call its method. Right, so this is how we write the code using traditional way. Now let's go and let's see how to use a Lambda expression to implement consumer functional interface. Well, it's pretty simple. So what we're going to do is we're going to simply copy this method and we convert this method into Lambda expression. Well, let me simply copy this method and paste within a main method and get rid of this add override annotation. And as we know that we assign a Lambda expression to the functional interface, so let's copy this reference and paste it over here. Now we have assigned this block of code to the functional interface. Let's make this method as a Lambda expression. So here we have already consumer, so let me simply comment out this code. Okay, and here public is not make sense in case of Lambda expression, because public makes sense in case of method or variable, okay, instance variable, but Lambda expression is not belong to any class or object, so we can remove the public access modifier from here. And Lambda expression don't have name because Lambda expression is an anonymous function, so just get rid of this function name as well. And what remains here, void. So we don't have to specify a return type to this Lambda expression because Java compiler is smart enough to identify the return type by looking into the return type of this accept method. So get rid of this return type from here, and then let's put the arrow symbol over here, and then finally let's put the semicolon at the end of the Lambda expression. Now this is your Lambda expression. Okay, now let's simplify on further. So this Lambda expression body contains exactly one statement, so we can also get rid of this open and close curly braces. So let me quickly remove this. Alright, and if you can see here type, so we can also remove this string type from here because Java compiler is smart enough to identify the type for this parameter. Okay, so Java compiler will basically look into this accept method and its parameter type here. For example, the parameter type is string, right? So Java compiler will automatically identify the type of this parameter, so get rid of this parameter type. Now this is the simplified version of Lambda expression. Now let's go and let's call the accept method over here, consumer dot, and then call accept, and then simply pass hello world. Perfect. Now let's run the program and let's see how this works. And there we go, hello world is printed in a console. Well, if you can see the lines of code here, without using Lambda expression we have to write a lot of code. For instance, we need to create a class which implements consumer functional interface, and then we need to override this abstract method, and we need to provide the implementation, isn't it? And again we need to create object of this class, and then we need to call the method. Well, if you can see here, using Lambda expression we can reduce a lot of code. Well, here we have written 2 lines of code using Lambda expression, and without Lambda expression we have written this much of code, right? So Lambda expression basically reduces a lot of code, right? Yeah, that's it. I hope we understood how to use a consumer functional interface and how to implement consumer functional interface using Lambda expression. Well, basically consumer functional interface, it takes an input and it does not return anything, okay? And this is how we use a Lambda expression to implement the consumer interface. Now let's take a look into supplier functional interface. Well, supplier functional interface is a generic interface. You can see here we need to pass a type, okay, and this type is basically the result supplied by this supplier functional interface. And supplier functional interface has a method called get method, right? So we basically use a Lambda expression to implement this get method, and this get method does not take any parameter. It does not take any input, and it should return a result to the client, okay? So let's go and let's see how to use a supplier functional interface. Well, basically supplier functional interface, it supplies some data to the client, okay? So let's go to IntelliJ IDEA and let's create an example to demonstrate supplier functional interface. So let's create a class and let's call it as supplier demo. Well, as usual, first we'll see the traditional way, and then bit later we'll see how we can use a Lambda expression to implement the supplier functional interface. So let's create a class and let's call it as supplier IMPL, and this implements supplier functional interface. And make sure that you choose a supplier functional interface from java.util.function package, and then this is generic, so we have to pass the type, right? So in this case we are going to create an example to return the current date time, okay? For that, let's pass the local date time here, okay? Local date time as a type. Now let's override the get method and let's provide the implementation. Well, we simply need to return the current date time, right? So for that, let's call the local date time and then call its method now. Okay, so this will basically return the date and time, current date and time, okay? Simply save it and go to the supplier demo class. Within this class, let's create a main method and let's create an object of this supplier functional interface implementation over here. Let's call it as supplier and then new and then supplier IMPL. Alright, and simply put this out. Alright, and then call the supplier object here and then call get method. That's it. This will print the current date time, right? So let's run the program and let's see how this works. And there we go. Alright, it means that we have successfully implemented supplier functional interface using traditional way. Now let's see how we can use a Lambda expression to implement the supplier functional interface. Well, let me use this method and let me convert this method into Lambda expression. So here I am going to comment out this code first, and then I'm going to paste the method over here and then simply get rid of this annotation, and let's assign the Lambda expression to the functional interface like this, and let's remove the unnecessary parts. So get rid of this public, get rid of the method name, and then get rid of this return type is not required, and let's put the arrow symbol and put the semicolon at the end of the lambda expression. Now this is your lambda expression. All right, and we can also simplify this lambda expression further. For example, this lambda expression body contains exactly one statement, so we can also get rid of this open and close curly braces, and also we can remove this return keyword from here. Alright, perfect. So this is your simplified lambda expression, and then simply call sysout and then call get method. Okay, now let's go ahead and let's run the program and let's see how this works. And there we go, this is working as expected, right? So this is how basically we use the lambda expression to implement supplier functional interface. Well, supplier functional interface, it basically supplies some data to the calling function. Here this get method basically supplying the current date time. Well, basically runnable interface in Java is a functional interface, so we can use a lambda expression to implement a runnable functional interface, and then we can create a thread, and then we can pass the lambda expression to the thread. All right, so let me create an example and let me demonstrate how we can write a lambda expression to create a thread. Let me head over to the IntelliJ IDEA. Well, go to the package, right click on the package, new, and then choose Java class, and let's give class name as something like Runnable Lambda example, and hit enter. Now first we'll see how to write a code using traditional way, and then later we'll see how to write the same code using lambda expression. So here we'll create a class which implements runnable interface. Let's say thread demo class which implements a runnable interface, and then simply override the run method over here. Just mouse over, click on implement methods, choose run method, and there we go. And to keep it simple, within the run method we'll put a sysout and just print run method called something like this. Okay, now go to the runnable lambda example class and then create a main method, and within a main method we are going to create an instance of thread class. So let's create object of thread here, and then pass object of thread demo. Okay, and then simply start the thread here. Okay, so this is how traditionally we create a thread object. Okay, we create a class, implements runnable interface, and then we override the run method and we provide the implementation for run method, and we create a thread instance here, and we pass the object of thread demo class, and then we start the thread. Okay, so this is how we create the thread using traditional way. Now let's go and let's see how to use a lambda expression to implement a runnable interface, and then we will create a thread object. Okay, well, if we can go inside runnable interface source code, you can able to see runnable is a functional interface because runnable contains only one abstract method, that is run method. And if you can see, runnable interface is annotated with add functional interface annotation. It means runnable is a functional interface, and we can use a lambda expression to implement a runnable interface. Alright, so let's go back to our class, and here we're going to use a lambda expression to implement a runnable interface. Let's use a runnable functional interface reference variable to assign the lambda expression. So this is the syntax of the lambda expression, right? And simply put on sysout within a lambda expression body and just call it as run method called using lambda, something like this. Alright, and then we need to create instance of thread over here. Thread, let's say lambda equal to new thread, and then pass runnable, and then simply start the thread. Perfect. So this is how basically we implement a runnable functional interface using lambda expression, and then we create a thread object, and then we pass a lambda expression implementation as a parameter to this constructor, and then we start the thread. Okay, so let me run the program and let me show you, and there we go. So this is working as expected. Well, we can simplify this lambda expression even more. If you can see here, lambda expression body contains only one statement, so we can get rid of this open and close curly braces over here. All right, perfect. And if you can see here, we can simply pass this lambda expression itself as a parameter to the constructor. For instance, I'm going to pass here and I'm going to get rid of this statement. Okay, so this is how we can pass a lambda expression as a parameter to the constructor as well. If I run the program, it should work, and there we go. All right, so this is how basically we use a lambda expression to implement a runnable interface, and we pass that lambda expression to the thread object, and then we start the thread. Well, Java method references are basically introduced in Java 8. Well, method reference is used to refer a method of a functional interface. It is basically a compact and easy form of lambda expression. Well, each time when you are using lambda expression to just referring a method, you can replace your lambda expression with the method reference. Well, basically we use a method reference to replace the lambda expression. Well, for example, look at here the code snippet over here. This is the lambda expression just to refer a method. For example, system.out.println. So println is the method, out is the object. Okay, so this lambda expression is just to refer the method, that is println. So we can easily replace this lambda expression with the method reference. And here you can see the syntax of converting the lambda expression into method reference. So basically we remove this lambda expression and we provide a double colon here in between object and function, like this. So this is basically a method reference. Okay, here we are just referring to the method using method reference. Alright, so just remember, each time when you are using lambda expression just to referring a method, you can replace your lambda expression with the method reference. Well, let's take a look into the types of method references. Well, there are basically 4 types of method references. First one is method reference to a static method, and here is the syntax: class, double colon, and then static method. So whenever we use a method reference to call a static method, and this is how the syntax looks like. Second is reference to a instance method of a particular object, and this is the syntax. So this is the particular object, and then we are using method reference to call its method. Third is reference to an instance method of an arbitrary object of a specific type, and this is the syntax. Okay, so this is the class and this is the method reference to a instance method. Okay, and fourth is reference to a constructor, and this is the syntax: class name, double colon, new. Okay, don't worry, I will explain these 4 types with an example, so you will be easily able to understand the types of method references. Alright, now let's go ahead and let's head over to the IntelliJ IDEA and let's implement these 4 method references with an example. So first we will see method reference to a static method. Well, head over to the IntelliJ IDEA, and here I am going to create a new package and let's call it as method reference. Hit enter, and then within this package let's create a class and let's call it as method references demo, something like this. Hit enter. Alright, and within this class let's create a main method, and first we're gonna see method reference to a static method. Okay, so first we're gonna write a lambda expression and then we'll convert that lambda expression with the method reference. Okay, so each time you have a lambda expression which is just referring to a method, then you can easily replace that lambda expression with the method reference, right? So now let's go ahead and let's create a lambda expression first. We're going to use an inbuilt functional interface, that is functional interface, and just pass here an integer and double as a type to this functional interface. Now let's go ahead and let's assign a lambda expression to this functional interface. So here is the syntax. We need to pass the input, alright, and arrow symbol, and then this example is basically to calculate the square root of a number. In order to call the square root method, we're going to use math class from java.learn package. It has a square root method, right? So we can use this inbuilt method to calculate the square root of a number. So here I'm going to pass input. Alright, so this is the lambda expression, and just push the sys out and then function dot apply and then pass the number, let's say 4. We're going to calculate the square root of number 4. Now let's go and let's run the program and let's see the output. And there we go. The square root of number 4 is 2, right? Now let's go and let's replace this lambda expression with method reference. Okay, so this is using method reference. Well, in order to convert this lambda expression into method reference, what I can do is I can simply copy this and paste it here. And now let's convert this lambda expression into a method reference. So let me rename this, let's say function method reference. And in order to convert lambda expression into method reference, it's pretty simple. We have to first remove this part, and in case of method reference we don't have to pass the parameter, so remove this and put the semicolon and just replace this dot with double colon. That's it. This is your method reference. Alright, so this is how you can convert a lambda expression into method reference. Okay, so each time you have a lambda expression which is just referring to a method, then you can replace this lambda expression with the method reference. For example, so here you can see this is a lambda expression. It is just referring to a method called square root. Okay, and we can easily replace this lambda expression with the method reference like this. Now what we can do, we can put a sys out over here and then call function method reference and then call apply and then pass the number. That's it. Now let's run the program and let's see the output. And there we go. This is working as expected, isn't it? So this is how basically we use a method reference to a static method. Okay, so this is how we use the method reference to call a static method, right? So let's take a look into one more example to demonstrate method reference to a static method. So here what I'm going to do is I'm going to create one static method here. Let's say public static, it returns integer, and let's say addition is the method name, and then pass int a comma int b. Okay, and this should return addition of a plus b. Alright, perfect. Now we're gonna see how we can write the lambda expression to call this static additional method, right? So here what I'm gonna do is we're gonna first write the lambda expression and then we will convert that lambda expression with the method reference. Well, in order to write the lambda expression for this static method, we're gonna use by function functional interface. For example, by function functional interface, and it takes 3 types. Okay, so let's pass the type integer. So here we're gonna pass a wrapper class integer because this is a generic, right? So generic don't support primitive, so we have to pass the wrapper class. And then let's call it as by function. Let's say by function lambda, and then we create a lambda expression and then we assign that lambda expression to this functional interface. So here is the syntax for the lambda expression: a comma b and then arrow symbol, and then we're gonna call the static method. So we use a class name to call the static method, right? So let's have a class name here, that is method reference demo, and then call a static method that is additional and then pass a comma b. It's pretty simple lambda expression, right? Now let's put a sys out and then by function lambda and then call apply method and then pass 10 comma 20. Alright, now let's go and let's run the program and let's see how this works. And there we go, 10 plus 20, 30, right? Now let's go and let's see how we can replace this lambda expression with the method reference. So here I am going to write the comment, let's say using method reference. Alright, so in order to convert this lambda expression into a method reference, I am going to simply copy this and paste it over here, and then let's rename this, let's say by function. And in order to convert a lambda expression with a method reference, we need to first remove this part, and method reference don't have parameter, so remove this parameter list and then put semicolon and then replace this dot with a double colon. So this is your method reference, and then again put this is out and then call apply method and then pass 10, 20. Pretty simple. Now let's go and let's run the program, and there we go. Alright, it's working as expected. So this is how basically we use a method reference to call a static method. It's pretty simple, right? Now we understood the first type of method reference, that is method reference to a static method. Now let's go and let's take a look into reference to a instance method of a particular object. Alright, let's head over to the IntelliJ IDEA and let's create an example. Well, let me write the comment over here. Method reference to an instance method of an object. Well, in order to demonstrate this type of method reference, first I'm going to create one functional interface. So let's have an interface, and then let's call the interface name as printable, something like this. Alright, and just create one method. Let's call it as print and then pass the string as a parameter, let's say message. And in order to mark this interface as a functional interface, we can also use add functional interface annotation. Alright, now within this class I am going to create a method public and let's say void, and let's give method name as display. Alright, and then just pass string as a method argument to this method, string message, and put the sysout over here. Or first what we're going to do is we're going to convert this message into uppercase, okay, to uppercase, and then we're going to put this out and then we print the message. Alright, perfect. So what we have done, basically we have created printable functional interface and we have created this display method, and then we have simply converted this input string into uppercase, and then we have just printed this string. Alright, now let's go and let's first see how to write a lambda expression to implement this printable functional interface, and then we'll later convert that lambda expression into method reference. Well, here we are going to demonstrate method reference to an instance method of an object, right? So first we need to create an object. So we're going to create an object of this class. Okay, so let's go and let's create an object of this class first, and then we call a method, its method, right? So let's say method references demo equal to new method references to demo, and then what we're going to do is we're going to write the lambda expression first, and then we'll convert this lambda expression into method reference. So basically we use a lambda expression to implement a functional interface, right? In our case, printable is the functional interface, and here is the syntax. Let's pass a message as the input, and then we have an object and then call its method called display and then pass the message. So this is how basically we write the lambda expression to implement a functional interface. And if you can see here, this display method should have the same parameter and should have the same return type of this abstract method, right? So if you can see, print method has a return type void and has a parameter of type string. Okay, then only you can able to assign this lambda expression to this functional interface. All right, I hope you understood this one. Now let's go and let's call this method printable dot print and then pass something like hello world. All right, and then let's run the program and let's see how this works. And there we go, the hello world string is converted into uppercase and then it is printed to the console. Alright, so this is how we write the lambda expression to implement this functional interface. And if you can open display method, so display method should have the same return type and same parameter type. Okay, that's why we can able to implement this method using lambda expression, and then only you can able to assign to the printable functional interface. All right, now let's go and let's convert this lambda expression with the method reference. Well, if you are using IntelliJ IDEA, then you can have a shortcut over here. So just click on display and just enter, alter and enter, and you will get option here like replace lambda with the method reference. So you can use this option to convert a lambda with method reference. Okay, so this is how you can see in IntelliJ IDEA. Okay, IntelliJ IDEA will basically provide a shortcut to convert lambda with the method reference. All right, but we're going to convert manually this lambda expression with the method reference. So now I'm going to simply write the comment here, let's say using method reference, and then I'm going to paste this line, and let's convert this lambda expression with the method reference. So let's call it as printable method reference. And in order to convert this from lambda expression with the method reference, let's remove this lambda part, and let's also remove this parameter list, put the semicolon, and remove this dot with the double colon. So this is your method reference, and then simply call printable method reference dot print method, and then pass hello world. All right, and then let's go and let's run this program and let's see the output. Well, let me run the program, and you can able to see hello world string is converted into uppercase and it is printed to the console. All right, so this is how basically we use a method reference to an instance of an object. So this is basically object, and we are calling its method using method reference. That's why method reference to an instance of an object. Okay, so this is the object and this is the its method, and we are using method reference to call a method of this object, right? That's the reason this is the name. Well, so far we have seen method reference to a static method and reference to an instance method of a particular object. Now let's go and let's see reference to a static method of an arbitrary object of a specific type. Okay, so this is little bit confusion, but let me create an example so that you will be definitely going to understand this method reference type. Okay, let me head over to the IntelliJ IDEA. Well, here I am going to write the comment first. Reference to an instance method of an arbitrary object. Well, sometimes we call a method of argument in a lambda expression. In that case, we can use a method reference to call an instance method of an arbitrary object of a specific type. So let's go and let's create one simple example to understand this method reference type. So let's use function functional interface. Well, function functional interface basically takes a input and it returns the result. Okay, and just pass the type, first type as a string and second type as a string. All right, and let's call it as string function, and then pass a lambda expression, assign the lambda expression to this function functional interface. So here is the lambda expression syntax. Let's have an input of type string. You can also mention string like this. Okay, but we can remove this type. Compiler will automatically infer the type here by looking into this type here. Okay, so you can keep or you can remove. So let's put the arrow symbol, and then here what we're going to do is we're going to convert a string into lowercase by using string provided to lowercase method. I'm going to call input of type string and then simply call to lowercase. All right, so if you can see here, input is basically a argument or parameter of lambda expression, right? And here we are calling a method of this argument. Okay, so this is nothing but a reference to an instance method of an arbitrary object. So input is basically arbitrary object. Okay, if you can read this sentence over here, sometimes we call a method of argument in a lambda expression. If you can see, this is the argument of the lambda expression and we are calling its method over here. Okay, so this is basically called a method reference to an instance method of a arbitrary object. So if you have a lambda expression like this, then you can convert this lambda expression with the method reference. Okay, I hope you understood this method reference type. Well, whenever you have a lambda expression, it has an argument, and if you call its argument method, then you can replace this lambda expression with the method reference. Okay, now let's go and let's put the sys out, and then call string function, and then call its method apply, and here let's say Java guides. Okay, now let's run the program and let's see how this works. And there we go, Java guides is converted into lowercase. Now let's go and let's see how to replace this lambda expression with the method reference. So here let me simply copy this, and here first I want to write the comment here using method reference. Okay, and paste it here and simply remove this, and input is basically a string, right? So let's have a string here, and then replace this dot with double colon, and then replace this parameter list. Alright, this is your method reference, and this reference variable is already exist, so let's rename this. Let's say string function method reference. Okay, perfect. So this is how we basically replace this lambda expression with the method reference. If you are using IntelliJ IDEA, then you can use IntelliJ IDEA provided option to convert this lambda expression with the method reference. For example, just place this cursor on this method and then press Alt enter, and you will get option to replace a lambda with method reference, and just hit enter. So this will convert a lambda with method reference. Okay, so this is another option. Alright, so let me uncomment this, and let me put the sys out, and let me call the method, and let me pass the Java guides as a input. Okay, let me run the program and let's see how this works. And there we go. Okay, so the method reference that we have written is working as expected. Alright, so this is how basically we write the method reference to an instance method of an arbitrary object. Well, whenever you have a lambda expression with a method argument and you are calling a method of this argument, then you can go ahead and replace this lambda expression with the method reference. Okay, well, let me write one more example to demonstrate this method reference type so that you will understand better. So here I have created an array with these elements, and I am using arrays class to sort this array. Okay, so if you can see here, this sort takes two parameters. First one is a string array, and second one is the functional interface, and here we have provided a lambda as an implementation of functional interface, and this is lambda expression. And if you can closely observe this lambda expression, it takes s1 and s2 as a arguments, and you can see here s1 argument we are calling compare to ignore case method of this s1 argument. Okay, so this method reference states that whenever you have a lambda expression with an argument, and if you are calling the method of this argument, then you can replace this lambda expression with the method reference, right? So that is what we have done here. So here we have basically replaced this lambda expression with the method reference. Okay, so this is another example to demonstrate this method reference type. Well, let's take a look into the next type of method reference, that is a reference to a constructor. Well, let's head over to the IntelliJ IDEA and let me demonstrate this type. So here I am going to write the comment that is a reference to a constructor. Well, in this example, what I'm going to do is I'm going to convert a list into set, and then I will show you how we can replace the lambda expression with the method reference. So here first of all I'm going to create a list of fruits. Okay, let's call it as fruits, and then let's use array list implementation. Let's add a couple of fruits to this list. Let's say banana, fruits dot add, and then let's say apple, fruits dot add, and then pass mango, and then fruits dot add and then pass watermelon, something like this. Now let's convert this list into set using lambda expression. So we're going to use again the function functional interface. It takes two arguments. Let's say first argument is list of type string, okay, and second argument of type set. It takes again string as a type, and let's call it as set function, and then let's write the lambda expression and then assign to this functional interface. So we need to pass the list of string, right? That is fruits. Let's say fruits list. Let's call it as a fruit list, and then this is the arrow symbol. All right, and then here simply call new hash set and then pass fruits list. That's it. Okay, so whenever you pass a list to the hash set constructor, then hash set constructor will this will convert a list into set, right? So this is how basically we write the lambda expression to convert a list into set. Okay, now what we're going to do is we're going to put the sys out over here, and then we call apply method, and then we pass a list, let's say fruits. Okay, now let me run the program and let's see how this works. And there we go. All right, we have printed the set right here by using system.out.println. Now let's go and let's see how we can convert this lambda expression with the method reference. So let me simply copy this, and here I want to write the comment, let's say method reference, using method reference basically, and then paste it over here, and let's call it as set function method reference. Well, in order to convert this lambda expression with the method reference, first of all remove this part. All right, and parameter list is not required in case of method reference, so just put a double colon and then new. That's it. We have simplified a lambda with a method reference like this, right? And then put the sys out over here, and then set function method reference, and then call apply method, and then pass the fruits list. Okay, and then just go ahead and run the program, and let's see how this works. And there we go. So this is how basically we use a method reference to reference to a constructor. Okay, here we have object of hash set, and we have replaced this with a method reference to a constructor using method reference syntax, double colon followed by new. Well, whenever you have a lambda expression with this logic, then you can go ahead and use method reference to a constructor type like this. Alright, these are the 4 method references, and I have demonstrated all of them with an example. Alright, and these 4 types of method references are pretty important. So whenever you have a lambda expression which is just referring to a method, then you can go ahead and replace that lambda expression with the respective method reference type. Alright, I hope you understood what is a method reference and what are the different types of method references and how we can use method references to replace the lambda expression. Alright, we'll take a look into how to use optional class to avoid null checks and null pointer exceptions. Well, null pointer exception is one of the exception that frequently occur in day-to-day project work, right? And null pointer exception is like a close friend to the Java programmer, because whenever we write a program or whenever we work on Java project, then this null pointer exception will frequently occurs. All right, so in this course what we're going to do is we're going to see how we can use an optional class to avoid the null checks as well as null pointer exceptions. Well, why optional class? Well, before optional class we were writing a lot of null checks, right? For example, consider we have an employee class. It contains all these fields, right? And if you can see, this code snippet over here. Here we have a get employee method. So consider this get employee method is retrieving the employee object from the database, and consider we have a email which is null in a database. Okay, so here if we call a get email method on employee object, then this returns null because employee does not contain email ID. And if we call to lowercase method on null reference, then this definitely will give the null pointer exception, isn't it? And in order to avoid this kind of null pointer exceptions, we are adding a null checks, right? For example, employee not equal to null, and within that employee dot get id not equal to null, and again employee dot get email id not equal to null. So here we have just added a null check for these two fields. What if we have a requirement to add a null check for other fields, right? So basically we need to write a lot of null checks over here. So adding this kind of null checks is not a good practice, isn't it? So we have to provide some solution for this. That is where the optional class were introduced. So optional class basically help us to avoid writing null checks, and it will also avoid to produce the null pointer exception. Now let's see what is optional class. Well, Java 8 has introduced a new optional utility class in java.util package. This class can help in avoiding null checks and null pointer exceptions. Well, if you can see this diagram over here, optional class, it acts as a single value container that either contains a value or does not. Okay, we'll see an example how optional acts as a container object. Now let's go ahead and let's head over to the Chrome browser over here, and here just type optional class java doc, and just go ahead and click on this docs.oracle.com. okay, so this will navigate to the optional class java doc. Alright, now let's go and let's explore some of the frequently used optional class method. And before that, you can see here optional is a final class. It means we cannot extend optional class, isn't it? And optional class is basically a utility class which is present in java.util package. Alright, and here you can see optional utility class provides some of the static methods: empty, off, op, null, label. So these three methods we can use to create a optional class object. And here are some of the instance methods. Okay, get, if present, is present, or else get, or else throw. Well, in example we'll see some of the frequently used optional utility class methods. Now let's go ahead and let's head over to the IntelliJ IDEA, and let's see the usage of frequently used optional utility class methods. Alright, we'll see how to create an optional class object, and how to get a value from the optional class object, and how to check whether optional contains a value or not, and how to get a default value, how to throw the exception. Okay, we'll see a lot of things using optional utility class. Now let me jump into IntelliJ IDEA. So this is the Java Lambda expressions project I have created in one of the previous video. So let's use this project for this optional class demo. Now here I am going to create a package. Let's call it as optional, and within an optional package I am going to create a class. Let's call it as optional demo. Alright, now within a class let's have a main method, and here we're going to first see how we can create an optional object. So basically there are several ways to create an optional object. For example, we can use op method, we can use empty method, and also we can use op null label method. So these are the three static methods that we can use to create an optional object. So let's go and let's see how to use all of these three methods to create an optional object. So first we will see how to create an empty optional object. So here let's type optional, and make sure that you choose optional from java.util package, and then call its static method, that is empty method. Now let's go and let's assign the value of this empty method in a local variable. So go ahead and introduce a local variable over here, and just give the variable name as empty optional. Hit enter, and we're gonna put on sysout and just print empty optional. Okay, so before running this program, let's deep dive into empty method and let's see its internal implementation. So let me jump into empty method over here and let me go to this empty, and you can see here this empty method returns basically a empty object of this optional class. Okay, great. Now let me go back. Now let's go ahead and let's run the program and let's see what this empty method prints. Well, let me run the program now, and there we go. Empty method returns optional.empty string, right? And you might be wondering where this optional.empty string present. Okay, let me show you. So just go ahead and jump into empty method and just search for optional.empty, and it is present in toString method. So this is how we create an empty object using optional class. Now let's see how to create an optional object using op and op nullable methods. So here just have optional class and then call its static method, that is op, and then pass the value. So here what I'm going to do is I'm going to declare one variable. Let's say email equal to ramesh@gmail.com, and then I'm going to pass this email to the op method. Alright, and now let's store this, store the value of this op method in a local variable. So go ahead and just introduce local variable and let's call it as email optional, and let's go and let's put the sys out and print email optional. Well, before running the program, let's understand the usage of this op method. Well, let me jump into this op method, and you can see op method internally provides a null check here. You can see required not null method, right? So just remember, op method internally provides a null check for this given value, and if you can go to required non-null method, you can see it throws null pointer exception. If a given value is null, then it will throw the null pointer exception, otherwise it will return the value, right? So it means that whenever you are sure that this email is not null, then you can go ahead and use op method to create an instance of optional class object. Okay, so whenever you are sure that this email, any object contains a value, then you can go ahead and use op method to create an instance of optional class. Okay, otherwise it will give the null pointer exception. For example, now this email a variable contains a value, so it won't give you null pointer exception. For example, let me run the program, and you can see here it print the optional class object. Now if I assign a null to this email reference variable, then this will give a null pointer exception. You can see here, okay, this line, because optional method internally provides a null check for this given value by using objects.require non-null method. Well, I hope you understood the usage of op method. So whenever you are sure that the object that you are passing to this op method is not null, then you can go ahead and use op method to create an instance of optional class. Alright, now let's go ahead and let's see how to create an optional class object using op nullable method. Well, let's call the optional class and make sure that you choose optional class from java.util package, and then pass string, and let's call it as string optional equal to optional, and then call its static method, that is op nullable. And if you can see here, op nullable method returns optional class object, right? So go ahead and call op null method and then pass email. Alright, perfect. And then put this out over here and then print string optional. Okay, so now let's understand the usage of op nullable method. So let's deep dive into this method first, and here you can see if the given value is null, then this method returns a empty object of optional class. It won't provide the null check for this value. What it does, simply whenever this value is null, then it will return the empty object of optional class. It means that this opNullable method won't throw the null pointer exception, even though if you pass the object which is null. Okay, because you can see clearly, if the value is null, then this simply returns the empty object of optional class. This, right? Let me go back. And if if the object contains a value, then this method returns the object of this optional class, and it will simply pass the value to the optional class constructor. Whenever you are not sure that whether the object contains a value or not, then you can go ahead and use opNullable method, because this opNullable method won't throw the null pointer exception. Okay, it will handle the null pointer exception by returning a empty object of the optional class. Okay, so yeah, that is the usage of opNullable method. Now let's see the usage of opNullable method in an action. Now what I'm going to do is I'm going to pass null value to this email object, and let me run the program now, and you can able to see the null pointer exception. So this is the null pointer exception from this line of code. So let me comment out these lines of code for time being, and now let me again run the program, and you can see here this returns optional.empty, because we are passing the null value to this email object. That's why it is giving optional.empty string, right? So it is not throwing null pointer exception. In fact, it is just returning the empty object of optional class. Now let's pass the value to this email object. Let's say ramesh@gmail.com. Now let's run the program and let's see how it works. And you can see here this opNullable method returns the value of this object, right? So just remember, whenever you are not sure that whether this object contains null or not, then you can go ahead and use this opNullable method, so that it will internally handle the null pointer exception, and it simply return the empty object of optional class, right? If the value is null for this object, then it will simply return the empty object of optional class, or else it will return the optional class it contains a value. Alright, so these are the three static methods that we can use to create instance of optional class. Well, if you can closely observe this optional class object, it acts as a single value container because it contains a value. For instance, let me run the program, and here you can see optional is basically a single value container. It contains a value. Okay, so now you might be wondering how I can retrieve this value from the optional class object. Optional class provides a get method, so that we can use to get the value from the optional object. So let me show you how we can do that. So you can see here we have already a optional class object. Let me call here a get method on this optional class object, and now let me run the program, and you can able to see we have retrieved the value from this optional class object. Okay, just remember, whenever you want to retrieve a value from the optional class object, then you can go ahead and use get method. Now let's see the internal implementation of this get method. So let me jump into this get method, and here you can see if the value is null, then this get method simply throws no such element exception, and this is the exception message, that is no value present. It means that whenever we retrieve empty or null value from the optional class, then it will definitely throw this no such element exception. For example, let me show you this demo. So let me go back to optional demo class, and here let me assign a null instead of the actual value. Okay, now let me save it and let me run the program, and there we go. This get method simply throws no such element exception, because this opNullable method returns a optional empty, and then we are trying to get that empty, we are trying to get a value from that optional empty object. That's why it is throwing no such element exception, isn't it? So just we have seen its internal implementation, right? If you again jump into get method, you can see the value is null, that's why it is throwing this exception, and we have assigned a null value to this reference variable. Okay, I hope you understood the internal implementation of get method. Okay, so whenever you want to retrieve a value from the optional class object, then you can go ahead and use get method. Well, in real-time project, we don't call this get method directly. We need to first check whether the optional class contains a value or not, right? So in order to do that, we can go ahead and use isPresent method. For instance, let me write the code snippet over here and let me show you. So here I'm going to call a string optional object. It has a method called isPresent. So isPresent method returns a boolean value here. Alright, so whenever this optional class object contains a value, then this isPresent method returns true, or else it returns false, right? So go ahead and call this isPresent method over here. Alright, and then I'm going to print this optional object value within this if condition. Okay, or else simply let me put the sys out and let me say no value present. Okay, let me run the program and let me show you how it works. And there we go, no value present. Alright, this is how we use isPresent method to check whether the optional class object contains a value or not, and then based on that we call the get method. Now instead of passing null, if I pass the value to this email object, then this will print this statement. So let me here pass the email ID, that is ramesh@gmail.com. Now if I run the program, this should print ramesh@gmail.com. Alright, this is the usage of isPresent and get method. Now let's take a look into how to get a default value from the optional class object. Well, sometime we may have a requirement like if the value is not present in optional class object, then we have to get a default value from the optional class object. Well, basically optional class provides or else method which we can use to retrieve a default value. For instance, here I am going to demonstrate the usage of or else method. Well, let me comment out this code first. Now we have optional class object. It has a value email, right? Now here what I'm going to do is I'm going to say string optional dot or else method, and you can see or else method takes parameter of type string and it returns a string, right? So just go ahead and call this or else method and then pass here some default value, let's say default gmail.com. Alright, and let's take the value of this method in a local variable. So let's introduce a local variable over here and let's call it as default optional. Perfect. Now let's put the sys out and just print default optional. Now let's jump into this or else method and let's understand how this method works. Well, let me deep dive into this method, and if you can see here, if the optional contains a value which is not null, then it simply returns that value, otherwise it returns the default value. Okay, for example, here other meaning the default value, right? For instance, you can see we have passed the default value. Alright, it means that if this string optional object contains a value, then this method simply returns that value, otherwise it returns the default value. Alright, it's straightforward, right? If you look at its internal implementation, this method simply returns a value if it is not null, otherwise it returns the default value. Alright, pretty simple. Now let's go ahead and let's run the program and let's see how this works. There we go, ramesh@gmail.com. Because this string optional object contains the value, that's why it returns the value from the string optional object. If I mention this object as a null over here, then this should return the default value. So let me run the program and you can able to see it will print a default@gmail.com. Alright, so this is how the or else method works. Well, there is one more method, that is or else get method, which works similar to or else method. So let me demonstrate the usage of or else get method over here. So let me call optional, that is string optional over here, and then call its method, that is or else get method. And if you can notice here the difference between or else and or else get method over here. Or else method takes a parameter of type string, but or else get method takes a parameter of type supplier interface. So this is basically a functional interface. So we have to use a lambda expression to implement supplier functional interface. So let's go ahead and let's call or else get method over here and just pass the lambda expression and just pass value as default @gmail.com. Okay, so if you look at here, or else and or else get method, so both works similar way, and only the difference you can see the parameter type. So or else method takes string, or else get method takes a supplier interface, and we have used lambda expression to implement supplier interface. Now let me introduce the local variable here and let me call it as default optional 2, and let me put the sys out and let me print default optional 2 here. Alright, so let me just comment out this code and let's go ahead and let's run the program and let's see how this works. And this also prints the default @gmail.com because we have assigned a null value to this email object, right? So this should be a Gmail. Alright, now what we're going to do is we're going to assign the value for this email object. Now what will happen, basically this or else get method will return the actual value from the optional object. It won't return the default value. Alright, now let me run the program and let me show you. And there we go, ramesh@gmail.com. Okay, now let's take a look into the internal implementation of or else get method. Well, let me jump into this method, and you can see here, if optional class object contains a value, then this method should return that value, otherwise it returns whatever the value that we pass to the supplier interface or the lambda expression. Okay, it's pretty simple, and this works similar to or else method. Only the difference we can see the parameter type. Alright, so this is how basically we use or else get method to return the default value. Well, there is one more method, that is or else throw method. Well, sometime we may have a requirement like whenever a value is not present in optional class object, then we have to throw the exception, right? In that case we can use or else throw method. For example, let me demonstrate this. So here what I'm going to do is I'm going to call string optional dot or else throw, and you can see there are two or else throw method. We're going to use this one because we're going to explicitly throw the exception, right? So just go ahead and call or else throw method, and it takes supplier interface, so we have to use lambda expression to implement this supplier functional interface. So let's go ahead and let's call this method. Alright, and here what we're going to do is we're going to use a lambda expression, and we're going to use illegal argument exception over here. Okay, and we can pass the message something like email is not exist, something like this. Now let's introduce a local variable over here, and let's give a name something like optional object, something like this. Hit enter. Alright, and now let me put the sys out and let me print the optional object. Now if you can see this string optional class object, it contains ramesh@gmail.com value. Hence this or else throw method simply returns this value. Okay, it don't throw this exception. Okay, so let me run the program and let me show you. And there we go, ramesh@gmail.com. right? Now what I'm going to do is I'm going to assign a null value to this object, and now this or else method would be able to throw this exception. Now let me run the program and let me show you the same. And there we go, illegal argument exception, email is not exist. Okay, so whenever we have a requirement like if the optional object contains a null value, then you can go ahead and throw the exception by using or else throw method. Alright, so this is how basically in real-time project also we use or else throw method a lot to throw the exception if the optional class object don't contain a value. Okay, great. Now let's go ahead and let's take a look into the internal implementation of or else throw method. So let me jump into this method, and here you can able to see if the optional class object contains a value, then this method simply returns that value. Otherwise it simply throw the exception. Okay, it's pretty straightforward, isn't it? Alright, I hope you understood the usage of or else throw method. Alright, so whenever this optional object contains a null value, then this method should throw this exception. Okay, great. Now let's take a look into one more important method, that is if present method. If present method. Okay, so here what I'm going to do is I'm going to create an optional class object of type string, and then let me call it as gender. Alright, and just create an optional object by using op method, and here I'm going to pass a male. Okay, and let me similarly create one more optional object over here, and let me call it as gender or empty optional. Okay, and let me create a empty optional object. So in order to do that, call the empty method. Okay, perfect. Now let's go ahead and let's see the usage of if present method. Here I am going to call gender optional object and then call if present method. If you look at the if present method parameter over here, it takes a consumer as a functional interface, right? So we're going to use a lambda expression to implement this consumer functional interface. So let me call this if present method over here, and let's use the lambda expression, and let's put the sys out over here and just print something like value is present. Alright, perfect. Now let's go ahead and let's run the program, and let's see how this if present method works. So let me run the program, and here is the exception. So this exception is because of this lines of code, so let me comment it out. Now let me run the program, and let's see the output, and there we go, value is present. This string is printed to the console, right? It means that if this object, that is optional object, contains any value, then this if present method will simply execute this code. Here what I'm going to do is I'm going to call if present method on this empty optional object. So here I'm going to call if present method, and simply I'm going to pass the lambda expression, and I'm going to put the sys out, and let's say no value present, something like this. Now let me run the program, and let me show you the output, and there we go, value is present. It means that this if present method simply printed value is present because this gender optional object contains a value male, right? That's why this if present method just printed this value is present string, and this second if present does not printed this no value present string because it is called on empty optional object, right? Because empty optional object does not contain anything, it is simply a empty, right? If you look at the internal implementation of if present method, you would be able to understand easily. So let me jump into if present method over here. You can able to see if the optional class object contains a value, then only it will execute this code, otherwise it don't execute anything. Okay, and this method is simply returns a void over here. I hope you understood the usage of if present method. Well, optional class contains a filter method. Now let's take a look into how we can use a filter method of optional class. Well, here first of all what I'm going to do is I'm going to write the code without using optional, and then bit later we'll see how we can use a optional filter method. So here I'm going to create a string object, let's say result equal to ABC. Perfect. So without using optional, we need to use a if condition for the null check, right? So here let's say result not equal to null, and result dot contains ABC, and then what we're going to do is we're going to print the result. Okay, let's consider this is the code. Okay, so this code simply check the null check this object, and then it will also check this condition. If both the condition are true, then only it will print this result. Okay, now let's see how we can use the optional class filter method to convert this null check. Okay, so here what I'm going to do is we're going to convert this object into optional first. So let's use optional over here and pass string as a type, and let's call it as optional string equal to optional, and then let's use op method and then pass a result. Okay, now we have created optional object and we have passed abc to this optional object. Now the optional object contains abc value. Okay, now let's see how we can use a filter method to add this condition. Okay, now what I'm going to do is I'm going to use optional string here, and then I'm going to call its filter method. Well, if you can see the parameter of this filter method, the filter method takes predicate functional interface as a method parameter, right? So we have to use a lambda expression to implement this predicate functional interface. So here what I'm going to do is I'm going to call this filter method, and then let's say result, and this is a lambda expression, and here what I'm going to do is I'm going to say result dot contains abc. Okay, now we have added a filter for this optional object. Well, what we have done, basically we have called this filter method on optional class object and we have added this condition. Okay, next we need to print the result using sysout, right? So here what I'm going to do is I'm going to call one more method over here, that is if present. Okay, if the optional class object contains any value, then only this method will execute. So let me call if present over here, and let me use the lambda expression to implement the consumer functional interface. So look at here, if present method takes consumer functional interface, right? So let me put the sysout and let me simply print the result. Okay, so this is how basically we use a filter method on optional class object to add the condition on the optional object value. Okay, now what I'm going to do is I'm going to run the program, and yeah, so let's see how this works. And you can able to see abc. It means that the given condition, the condition that we have added using filter method is returned true. That's why we can able to print this result using this if present method. Okay, so this is how we can use the filter method to apply some condition on the value of optional class object. Okay, it's pretty simple. Well, optional class provides one more very useful method, that is map method. Okay, so let's see the usage of map method. Well, map method in a optional provides a way to transform value in a optional from one type to another type. For example, let's consider this example itself. So here we just change the value. So this value now contains the spaces. Okay, now let's convert this value into without space. All right, so here after filter method I'm going to call a map method here. Okay, and you can see map method takes a function as a method argument, and function is basically a functional interface, so we can use a lambda expression or method reference to implement this functional interface. So let me simply use the method reference over here, string and then method reference, and here I am going to simply trim the spaces. Okay, I am going to call trim method over here. Well, it's pretty simple. So we just need to remove the spaces and we need to convert this string into another string by using map method. Okay, now let's go ahead and let's run the program and let's see how this map method works. And there we go. All right, it simply prints a abc, right? It means that we can use a map method to transform a value in optional from one type to another type. All right, so this is how we can use a filter and map method to add some condition or convert from one value to another value on an optional class object itself. Okay, so these are the few very important optional class methods or APIs that we frequently use in our day-to-day projects, right? So I hope you understood the usage of all these optional class methods, because these methods we frequently use in our day-to-day project work. So just take a look into all these methods and have some hands-on experience. Alright guys, I hope you understood how to use the APIs or methods of optional utility class. Well, Java 8 basically allows us to use default and static methods in our interfaces. Alright, in this video we're going to see how we can use default and static methods in our interfaces with an examples. Well, first let's take a look into why do we need the default methods in our interfaces. Well, let me explain you why do we need a default methods in interfaces with an example. Well, consider in your project you have this kind of hierarchy, like you have interface and you have multiple implementation classes which implements the interface. Okay, so consider in our example we have a shape interface. It has a draw method. So basically draw is an abstract method, and here we have rectangular, square and circle. So these are the three implementation classes of shape interface. Now we have a requirement to add one or more methods to the interface. Then what will happen, basically the implementation classes should have to implement those newly added methods. For instance, let me add one method over here. Let's say m1, and m1 is an abstract method. So all the implementation classes have to override this method and provide the implementation, isn't it? But my requirement is like I need to implement this method only in rectangle and square. I don't want to implement this method in a circle. Alright, but this don't allows us to unimplement this method in this circle implementation class, because this is abstract method and we have to override this method and provide the implementation. Otherwise we will get the compilation error like this, isn't it? So in order to deal with this kind of issue, a default methods were introduced. So once we use a default method, what will happen, basically the default method will be automatically available to all these implementation classes. We don't have to override the default method. Okay, for example, let me quickly create a default method over here. Default void m1. So this should be default. Okay, let me put one sys out and let's say m1 default method, something like this. Now this m1 default method will be automatically available to rectangular, square and circle. Okay, so in this way the default interface method will resolve this kind of issue, and default method will automatically available to all the implementation classes. Therefore we don't need to modify the implementation classes. Okay, so in this way backward compatibility is neatly preserved without having to refactor these implementation classes. So this is why the default methods were introduced in the interface. Okay, so default method is mainly used to preserve the backward compatibility. Okay, so once we define the default method in the interface, that default method will be available to all the implementation classes. We don't have to add the abstract method and forcefully implement in all the existing implementation classes, right? So I hope you understood why do we need a default methods in a interfaces. Well, let's go ahead and let's create an example to understand more about default methods. Well, we are going to use the existing project. So let's create a new package and let's call it as default static. Hit enter. Let's go and let's create a new class. Let's call it as default demo. Alright, now what we're going to do is we're going to define the interface, and within interface we'll define a couple of default methods, and within a vehicle interface we're going to define few of the abstract methods and few of the default methods. Let's first define the abstract methods. Let's say get brand. So this is going to be a vehicle brand. Let's say one more abstract method. Let's call it as speed up. Similarly, let's create one more abstract method. Let's say slow down. Alright, so all the vehicles basically have this kind of interface methods, right? Now let's go ahead and let's create a couple of default methods. Well, in order to create a default method, we have to use default keyword followed by the return type of the method. Let's say string, and then let's call method name as turn alarm on, something like this. Well, to keep it simple, let's return some string from this default method. Let's call it as turning vehicle alarm on, something like this. Alright, so let's go and define one more default method. Let's say default, and the return type of the method is string, and then turn alarm off. Alright, and to keep it simple, let's return a string. Return turning vehicle alarm off, something like this. Alright, so this is how we basically create the default methods in a interface. So we basically use the default keyword, okay, and we don't have to specify the access modifier here, like public, static, public, private, protected. By default, the default methods uses public as a access modifier. Now let's go ahead and let's create a class which implements vehicle interface. So let's create a class over here. Let's give class name as car here, which implements vehicle interface. And if you can see here, we have defined 3 abstract methods, right? So this class should have to implement these 3 abstract methods. So let's mouse over it and click on implement methods, and by default IntelliJ IDEA will choose all these default methods over here. So turn alarm on, turn alarm off. So these are the default methods. We don't have to override because these default methods already provide the implementation, so we don't have to again override and provide the implementation, isn't it? So go ahead and click on OK. Well, to keep it simple, let's return some string for this get brand method. Let's call it as BMW, okay, and speed up. So let's return some string like the car is speeding up, something like this. And similarly, let's give return type for slow down method as car is slowing down, something like this. Perfect. Now what we have done, basically we have created a class which implements vehicle interface, and we have overridden get brand, speed up, slow down methods, and we have provided the implementations, right? Well, we don't have to override these default methods in a car class because these default methods already provides the implementations, isn't it? And these default methods will be automatically available to this implementation class. Alright, so let me demonstrate how these default methods will be automatically available in a car implementation class. So here what I'm going to do is I'm going to create a main method, and within a main method, let's go and let's create an instance of car class. I'm going to use here vehicle interface reference. Okay, perfect. Now what I'm going to do is I'm going to call the abstract method first. Let's say get brand, okay, and then I'm going to call speed up method, and then call get or slow down method. Okay, so these are the abstract methods that are automatically available because we have explicitly overridden these methods and we have provided the implementations, isn't it? Now let's see how the default methods will automatically available to this car implementation class. So here what I'm going to do is I'm going to say vehicle dot turn alarm on and turn alarm off. Okay, so these default methods are available to this class. Okay, so let's call turn alarm on and then vehicle dot turn alarm off. Alright, so it means that the default methods we have defined in the interface automatically are available to its implementation class, right? So here you can see turn alarm on and turn alarm off. So here we are using interface as a reference variable. So if we use car here, this also the same. Alright, so by looking into these 2 lines of code, we can clearly see that the default methods we have defined in a vehicle interface are automatically available to this car implementation class. Alright, in this way we can preserve the backward compatibility. So whenever you want to define some functionality, then you can go ahead and define in a interface by using default method. You don't have to forcefully override the method in a implementation classes. Alright, so this is how basically we create a default method in the interfaces, and this is how we call the default methods using implementation class object. Okay, now if you run the program, this should work. Okay, so we haven't printed anything, so let me quickly put the sysout and let me print the result of these methods. So let me put the sysout and let me pass this call. Okay, so let me similarly do it for all these method calls. Sysout and then pass this method call, and similarly put sysout over here and then simply pass this method call and put sysout and simply call this method call. Now we are good to run our program, and there we go. The vehicle brand is BMW. Speed up, it returns the car is speeding up. Slow down method returns the car is slowing down. And turn alarm on method returns turning vehicle alarm on. Turn alarm off method returns turning vehicle alarm off. Okay, it means that the default methods are automatically available to its implementation class. Alright, I hope you understood how to create a default methods in the interfaces and how you can call the default methods. Alright, great. Now let's go ahead and let's quickly take a look into how to create a static method in an interface and how to call the static methods. Well, let me take this example itself. So here within a vehicle interface, I am going to create one static method. So in order to create a static method, let's use static keyword here, and let's give static method return type as a string, and let's give a method name something like company. Okay, the vehicle company, and let's return the vehicle company name something like BMW. Alright, perfect. So this is how we basically define the static method in a interface. Alright, well, probably you have created a static methods in a utility classes, right? So same way we create a static method in a interfaces like this. Okay, and in order to call the static methods which are defined in a classes, we have to use the class name, isn't it? So similar way, in order to call the static methods which are defined in interfaces, we have to use interface name. Okay, so let me demonstrate how we can call the static methods which are created in a interface. So go to main method here, and here what I'm going to do is I'm going to put sysout, and then I'm going to use vehicle, that is interface name, to call the static method, vehicle dot get company. Okay, so this is how basically we call the static method using interface name. So let me simply run the program and let me show you, and there we go, the company name is BMW. Alright, so this is how basically we create a static method in a interface, and this is how we basically call the static method using interface name. Okay, well, whenever you have a requirement to create a utility methods or a static methods in a single place or a central place, then you can go ahead and create a static method in an interface like this. So let us understand what is a stream. A stream represents a sequence of objects from source which supports aggregate operations. Alright, so basically we create a stream from different sources like collection, arrays and IO resources, and stream supports aggregate operations. This we will see in the example section. Java provides a new additional package in Java 8 called java.util.stream. Look at here, Java provides java.util.stream package in Java 8, and this package contains interfaces, classes and enums. So we can use these classes, interface and enums to perform functional style operations on stream of elements such as map, reduce, transformations on collections. Okay, and we can use streams by importing this package in our Java programs. Alright, so look at here how stream works. Source is a stream of elements, and on top of stream we can perform filtering, sorting, mapping, and at the end we can collect the result and we can convert it into either list, set, alright, or map. And this is the collect, and we can also use a reduce operation at the end. Alright, so this is how typically a stream works. Like sources is like a stream of elements, on top of stream of elements we can perform filtering, sorting, mapping, and at the end we can collect or reduce the result. Alright, it's pretty simple. In example section we will understand a lot about stream. I'm in Eclipse IDE, and let's go ahead and let's create a new Java project. Go to the file, new, and choose Java project, and let's give a name as Java 8 Stream API or tutorial like this, and hit finish. And here we go, a project is created. Let's go ahead and let's create a package, and let's call it as com.javaguides.java.tutorial, something like this. And first we'll see how to create a stream, and also see how to create a stream from different sources. For that, I'm going to create a class here. I'm going to call it as create stream objects, and let's quickly create a main method, and let's first create a stream of array. Okay, so let's create a stream of type string, and stream provides overloaded op method, and we are going to put a array of elements like a, b, c, like this. And we can use a forEach method to print a stream elements. For example, stream.forEach method, and here just provide a system.out println like this. So this will print a stream to the console. Alright, so this is the method reference here we are using. Okay, let's go ahead and let's run this program, and look at here the output ABC. Okay, this is in a sequential manner. Now let us see how to create a stream from sources. Alright, so we are going to create a stream from the collection first, collection of type string. Alright, and now we have a collection of string objects. Now let's go ahead and let's create a stream from the collection. Stream of type integer string, stream2 collection dot call stream method here. Great, now let's go ahead and print this stream. I'm going to copy this, and I'm going to just print this stream to the console like this. So this is how we create a stream from the collection. So collection is the source, and we can create a stream from the collection source like this by using stream method. Alright, let's go ahead and let's run the program. Here is the output, look at here. Similarly, we can create a stream from the list and set. For that, I'm going to just copy this code, and here I'm going to replace collection with list, and here just I'm going to change the reference, and this is the stream3. Simple, right? So here we created a list of string object, and we created a stream from the list object like this, and we have printed this stream to the console like this. It's pretty simple, right? Let's go ahead and let's run this program. So look at here. Now let's go ahead and let's create a stream from the set. It's pretty easy. So look at here, we created a hash set, and we just pass this list to the hash set here. And once we got a set object, we can call a stream method to create a stream object like this. And here we have printed stream4 to the console by using forEach method. It's pretty simple, right? Now we have seen how to create a stream from collection, list and set. Now let's go ahead and let's see how to create a stream from the arrays. For that, I'm going to create a array here, string array of string objects like this, and I'm going to initialize this array with elements like a, b, something like this. Alright, and now let's go ahead and let's create a stream of type string. I'm going to call it a stream5, and here I'm going to use arrays dot stream method, right? Stream, and here we are going to pass a string of type array of type string. here. Alright, it is a string array. It's pretty simple, right? And I'm going to just print this stream to the console like this. It's pretty simple. We create an array and we use arrays.stream method to create a stream object like this. So this is how we create a stream object from collection as well as array. Let me just run the program, and here you can see the output of this program. Alright, now let us see how to do filtering using Stream API. For that, I'm going to create again a class here, and I'm going to name it as Stream Filter Example. Okay, and here I'm quickly create a main method, and we need a class that is product. So we are going to perform some filtering operations on product entity or a product Pojo class, and let's define few fields here. Private int id, private string name, and private float price. Let's quickly create a getter setter methods to access these private fields, and also create a parameterized constructor here. Right click source and generate. Alright, now what we will do, we will create a separate method or a common method which will return a list of products. I am going to create a method here. This will return a list of products. Product get products. Okay, and I make this method as static so that main method is also static, so it can access this method easily. So here I will create a list of products. HP laptop, Dell laptop, Lenovo, Sony, and Apple laptop. These are the products in a product list, and just go ahead and just return this product list from this method here. Now what we'll do, we'll filter some products from the product list. So we filter a product which has a price 25,000 here. So we filter all the products whose price is greater than 25,000. Alright, so let us see how to do this in a traditional way without using Stream API. Alright, so let us see how to do that. First we will see here, we create a list of product, and here I'm going to use array list again. And in a traditional way we were using a forEach loop, right? So here just get a list of products and let's iterate over it using forEach loop. And here we apply if condition, like if product dot get price is greater than 25,000, then what we do is we add that product to the list like this. Okay, it's pretty simple, right? So this is how we were filtering a list of objects in a traditional way. Now in order to print these products, what we need to do is we need to use again a for loop like this, and again we iterate over or loop over a product, and we use this out like this, and we print a product. So let's create a toString method. Right click and source and toString. This will print product object in a string format. So let's go ahead and let's run this program. Look at here the output. So this is how we use traditional way to filter out objects from the list. So what we have done, we have just applied a condition here to filter a products whose salary is greater than 25,000, and that product we have added to the list, separate list, and we have printed to the console by using for loop here like this. Now let us see how to do it using stream API. Okay, great. First what we'll do, we'll get a products and then we call a stream method on it. So first we convert list into stream like this, and then we call a filter method here, and we provide a lambda expression like this, product, and here what we'll do, we'll call a product dot get price greater than 25,000. Alright, and here what we'll do, we'll again call a collect method, and here we call a collectors to collect a stream back to list. Okay, it's a collectors, right? Collectors dot to list. Yeah, here it is. So this get products returns a list of products, and we call a stream method, and on top of stream we can apply filter or mapping or sorting, and here we are using filter. This filters a list of products. Alright, so basically here is the condition. So here we are filtering a product whose price is greater than 25,000, and finally we use collect method to collect the result and we convert it into list. So here I am going to store the result of this in a separate list. Just call a product here, and I am going to call it as list 2. Okay, so it's very simple, right? So look at here the line of code. In a traditional way we need to write a lot of code, but using stream API in a single line we can do the stuff like this. Alright, let me break this. So look at here how this looks like. Alright, it looks concise and neat, right? Now what we'll do, we'll use a forEach loop to iterate over a list. For example, here I'm going to use forEach, and here we just call a system dot out and println like this. It's pretty simple, right? So let's go ahead and let's run the program and let us see the output. So look at here the output. So both gives the same result. What I will do, I will just separate out this. I will put a sys out here, and I will separate the result like this. Let's run the program and let's see the output. So look at here, both results should be same. Alright, so this is how we use stream API to filter a list of products. Even what we can do is, instead of this, we can directly use a forEach method here to print a stream objects like this when you need to again store as result in list. So look at here, in a single line we can do the stuff like this. Alright, so let's run the program and let us see the output. Alright, so this is how we use a filter method to filter a stream of objects. Okay, great. First we'll see how to sort a list of string objects in ascending and descending order using stream APIs, and next we'll see how to sort a list of employee objects by their salary in ascending and descending order using Lambda expression and stream APIs. Next we'll see how to sort a list of employee objects by age in ascending and descending order using stream APIs. Next we'll see how to sort employee objects by name in ascending and descending order using stream APIs. So I'm going to create a line by line code to demonstrate all these use cases. Okay, let's switch to the Eclipse IDE and let's start developing examples to demonstrate all these use cases. Alright, let's get started. Alright, for that, here is the class and here is the main method. Inside that we are going to write a logic. So first we'll create a list of objects. For example, look at here, we have a list of fruits, banana, apple, mango, orange, and we are going to sort this fruits list in ascending order and descending order using stream APIs. Alright, let us see how to do that. So let's first sort a list in ascending order. For that, first we need to convert a list into stream by calling stream method, and then we just sort a stream using sorted API. So look at here, here are the two overloaded sorted methods, and we are going to use this one, and here we need to just pass the comparator with natural ordering. Just call the natural order. So this will sort a stream into ascending order. Now we need to convert this stream back to list. For that we are going to call a collect method, and collect method, here we need to pass a collectors and call toList method to convert stream into list. It's pretty simple, right? So what we have done, we have converted list into stream, and here we have called sorted method to sort a stream in ascending order, and then we converted back from stream to list. And here we need to store this list in different list. I am going to call it as sorted list. Okay, it's pretty simple. And let's print this to the console. Just provide a sys out here and sorted list. So let's run the program and let us see the output. So look at here, apple, banana, mango, orange. Pretty simple, right? So we can also use Lambda expressions to sort a list in ascending order using stream API. For example, instead of this we can pass the Lambda expression. So let us see how to do that. So this is the Lambda expression we have to use to sort a list in ascending order. Okay, we need to pass a Lambda expression to the sorted method to sort a list in ascending order. It's pretty simple, right? So let's provide a sys out here and let's print this list, sorted list, to the console. So look at here, apple, banana, mango, orange. Pretty simple, right? As I mentioned, there are two sorted overloaded methods. Now let us see one more sorted method which don't have any parameter. So this will by default sort a list in ascending order. Let me just print the list in a console and let's see the output. So look at here, apple, banana, mango, orange. So these are the three different ways we can use to sort a list in ascending order. Okay, now let us see how to sort this list in descending order using stream APIs. So it's pretty simple. So what I will do, I will just copy this code, and here I will just put a comment like descending order. So here I will just rename the list here, sorted list 2, and this is sorted list 3. Okay, so this will sort a list in ascending order. So I am going to just change it from natural order to reverse order. So this will print a list in descending order. Okay, and here in a Lambda expression, in order to sort this list in descending order, we can just swap the references like this. Okay, this will sort a list in descending order. So let's go ahead and let's run the program and let's see the output. So look at here. So fruits list is sorted in a descending order. So this is how we sort a list of string objects in ascending order as well as descending order using string APIs. Now let us see how to sort employee objects by their salary in ascending order as well as descending order using stream APIs. So in previous video I have created an employee class with ID, name, age and salary. So I'm going to reuse this class. So let us see how to sort an employee by their salary in ascending order first, and then later we'll see how to sort employee by their salary in descending order. Okay, so first we need to convert employees to stream. So here just call a stream method, and let's call a sorted method. So first we will see the anonymous implementation of comparator interface, and then we'll convert anonymous class implementation with Lambda expression. Alright, let's call a comparator anonymous implementation here. We'll just call a collect. Here we need to pass a employee, right? Employee type, and let's call a collect method. So this here we need to provide a collectors dot to list method to convert stream into list. Okay, and comparator provides a compare method. We need to implement here like this. Alright, and here we are sorting the employee by salary. So here we need to provide the logic o1 dot get salary, o2 dot get salary. Alright, so let's cast it into integer. So this will sort an employee by their salary, and here what we will do, we will just get this new sorted list in another list. I am going to call it as employee sorted list. Okay, and here what we will do, we will just simply print it. Let us run the program and let us see the output. So look at here, employees are sorted by their salary. Employee with salary 3,50,000 comes first, and then 4,50,000 and then 5 lakhs. It's pretty simple, right? Now let's convert this anonymous implementation into a Lambda expression. It's pretty simple. So what we need to do is we need to replace this method here, and we no need to have a return here, and here just provide a arrow. Alright, and here just remove this. I will just break this, okay, so that you will understand. That's it. It's pretty simple, right? And even we can also remove this type here. Alright, so this is the Lambda expression to to sort employee by their salary in ascending order. So let me run the program here and look at here the output. Okay, great. Now in order to sort employee by their salary in descending order, what we can do is we can just swap the references like this. Okay, let's run the program and let us see the output. So look at here, the employee with higher salary comes first, and then low salary like this. Okay, so we can replace this Lambda expression with comparator provided methods. For example, I am going to just copy this, and here what I will do, I will replace this Lambda expression with comparator dot comparing long, and here what I will do, I will just pass the employee, and this is the method reference, and I am going to call get salary. Okay, it's pretty simple, right? So here is a comparing long method, so we can just call it and we can pass a get salary method. This is the method reference, double colon syntax, and here we just provide ss out and just print this list to the console. So look at here. Okay, so just we are sorting employee in ascending order like this. It's pretty simple, right? So notice here comparator interface provides a couple of methods, comparing methods, which are very useful while sorting. All right, so now we have seen how to sort a list, employee list in ascending order using this comparator.comparing long method. Now let us see how to sort this employee list in descending order. Let me copy this here, and here again comparator provides a reversed method, so this we can use to sort employee in descending order. So let us test it. Let's put this out, and this is the descending order, right? Great. So let's run the program. So look at here, the employee with higher salary, that is 5 lakhs, comes first, and then employee with 4,50,000, and then employee Ramesh with 4 lakh salary. Okay, so this is how we sort the employee list in ascending order and descending order. It's pretty simple, right? So comparator method, comparator interface provides these APIs comparing long and reverse, so we can use these APIs to sort a employee list in descending order like this. It's pretty simple, right? Now let us see how to sort an employee by their age in ascending and descending order using Stream API. So for that I'm going to just copy this, and let us see how to sort an employee by their age in ascending order first. Here what we need to do is we need to just replace get salary with get age, and this comparing long with comparing int. Okay, that's it. Now let's print this to the console and let us see the output. So look at here, the employees are sorted by their age in ascending order. Now let's say how to sort an employee in descending order. So what we need to do here is we need to call the reverse method, and just I will rename this list, and I will print this list to the console like this, and let's run the program. So look at here, age 30 comes first, and then age 29. Okay, so this is how we sort an employee by their age in ascending order and descending order using Stream APIs. Now let's quickly see how to sort employee by their name in ascending order and descending order. For that, what I will do, I will just copy this code, and here let me paste it. Here what I will do, instead of get age, I am just going to call a get name, and this returns a string, so we need to call a comparing method, and I'm going to store the result of this into a list, employee sorted list 5, and I'm going to print this list to the console like this. Okay, so this will sort employee by name in ascending order. Alright, let me run the program and let us see the output. So look at here, the employee name is Pramod comes first, and then Ramesh, and then Sanjay, and then Santosh. Alright, now let us see how to sort employee by their name in descending order. So it's again pretty simple. So here what we need to do is we need to call a reverse method of comparator, and I'm going to just print this list in a console. So look at here, Santosh comes first, and then Sanjay, and then Ramesh, and then Pramod. So this is how we sort a employee by their name in ascending order and descending order using Stream API and comparator. It's pretty simple, right? Let me recap what we have discussed so far in this video. We have discussed how to sort a list of string objects in ascending order and descending order using Stream API, and we have seen how to sort employee by their age, salary, name in descending order and in ascending order using Stream APIs. Now let us see how to perform mapping operation using Stream API. We use stream.map method to map one object into another object. For example, this is the example to convert a list of string objects into uppercase. So this is the list of string object, and before Java 8 we were using forEach and null loop to iterate over a list, and we convert each string object into uppercase and then we add to the list. And here is a sysout. We will display list using sysout. And in Java 8 we use stream.map method to map a string object into uppercase, and finally we collect a result and we store it back into a list like this. It's a pretty simple example. In this example I am going to cover this use case. I am going to map a user object into user detail object using stream.map method. Alright, in typical web applications or REST API projects, we create a JP entities, right, and we map that JP entities directly to the relational database tables. Consider user is a JP entity and we fetch records from the database and we store it into a user JP entity, and we convert this user JP entity into user DTO object and we send this object back to the client. And I am going to use stream.map method to map user object into user DTO object. So this is the example I am going to cover here right now. So let me switch to the Eclipse IDE and let us see how to use stream.map method. And I also use collect method to collect the output into a separate list. Let us see how to do that. Let me switch to the Eclipse IDE and let us start creating example. So here I am going to create a class and I am going to name it as stream map collect example. Alright, and here I am going to quickly create a main method, and here what I will do, I will create a user class. Okay, and here I will quickly create a fields ID string username. Alright, private string password and private string email. Alright, now let's go ahead and let's quickly create a getter setters and parameterized constructor. Right click, source, generate constructors, select all and generate. Now let's go and let's also create a toString method. Great. Alright, consider this is our domain entity class or JP entity class. Now let's go ahead and let's create a user DTO class. Let's create a class, name it as user DTO, and consider when we map or when we convert user object into user DTO object, we don't want to send a password to the client. For that we will map all the fields except password. Alright, because we don't want to send a password to the client, right? So that is the use case I am going to cover here. So I am going to just copy all the fields, and we don't want to send password to the client, so I am going to remove this password field here. Great, and let's go ahead and let's remove this password, getter setters, and from the toString method like this. Okay, great. Now we have a user and user DTO class in place. Now let's go ahead and let's create a list of user objects. User equal new, we are going to use array list implementation of list interface here. Alright, users dot add new user, and here I am going to add a few user quickly. Now we have a user list with 3 users. Now what we'll do, we'll map each user object into user DTO object using stream.map method. So let us see how to do it. In traditional way, how we were doing is we are using a forEach method, and we are just iterating over a list of user objects, and we just convert user object into user DT object. Let me quickly show you how to do it. Here user, and this is users. Now let me create one more list to store user DTO object. I am going to call it as user DTO, and this is user DTO, users DTO. Alright, and here what we'll do, DTO equal to new user DTO, and here what we need to do is you just call getters here, get ID, user dot get name, and here user dot get email. That's it. And here we just add to the list. We don't want to declare user DTO object here. Like this. Okay, so this is how we do in a traditional way. We use for loop to iterate over a list of objects, and we just convert like this, and we store in a separate list here, and we use another for loop to just display this list like this, user DTO, users DTO, and here just put a sysout DTO like this, and just run the program. Here is the output. Okay, now let us use stream API to map user object into user DTO object. So I am going to just write here comment like using stream map method. Okay, it's pretty simple. What we need to do is we need to just get a collection, and we need to convert collection, that is list into stream, and then on top of stream we need to call a map method here. So look at here, map method accepts functional interface. Alright, and if you go into the internal implementation of map, this map requires a function interface as method argument. So function interface is a functional interface, and it has only one abstract method, that is apply, and it accepts a single method argument, and it will return object. Okay, the apply method can return the same object or a different object. It's pretty simple, right? Now what we'll do, we'll use this function interface here. First use anonymous implementation of functional interface. Now we want input as user, and we want to return user DTO object, right? Great. This function provides apply method, so let's go and let's override apply method here. And here what we need to do is we need to convert like this, user DTO and let's use a constructor, user dot get ID. Let's change the reference, user dot get ID, and here user dot get name, user dot get email. Alright, so look at here, this is how we basically use a map. So map is not like a hash map or map interface, it's just a method of stream API. Alright, this is just a method. Okay, this is not a like hash map or other interface. Now this is the functional interface, and this is the anonymous implementation of functional interface. Now we can use a Lambda expression to implement this function interface. So let us see how to do it. As we know that a lambda expression don't have name, so let's go and let's remove this part, and here we are going to use arrow. This is the syntax of lambda expression, and this has a single statement, so let's go ahead and let's remove this curly braces, and we also no need to return here because it is a single statement. And here we are going to remove this part. Alright, and let's close this. That's it. It's pretty simple, right? This is the lambda expression. Alright, now what we'll do, we'll use a forEach method to print object to the console. So here I am going to use again a lambda expression, user DTO. Alright, and here I will use open curly braces, sys out, user DTO. It's pretty simple, right? Now let's go ahead and let's run the program. Here is the output. Okay, so this is how we use stream API to map one object into another object. It's pretty simple, right? Now what we can do is, instead of forEach, we can use here collect method. Okay, if we want to store the result into a list, like here I want to store this user DTO objects into another list like this. So what I need to do is, I want to use collect method here, and here inside that I will use collectors, and this will provide a to list method. So this will convert stream into list like this, and the result will be stored in a list of user DTO objects. Now I can send this DTO list object to the client. Alright, and here what I can do, I can again use forEach method on a list, and here what I will do, I will provide sys out like this, system dot out println like this. This will print a user DTO object to the console. It's pretty simple. Let's look at here the result. Alright, it's pretty simple, right? So this is how we can use a stream.map method to map one object into another object, and it's very useful in in this case. And this is the real world scenario we typically use in Java projects or REST API applications. Alright, I hope you enjoyed this video tutorial. Now let us see how to use find first and find any method of stream. So we use find first and find any method to find element from the stream. So let's go ahead and let's see how to use these two methods. So first what we need to do is, we need to convert list into stream using stream method, and then we need to call find first method. And look at here, find first returns optional object describing the first element of this stream, or an empty optional if stream is empty. Okay, and let's go ahead and let's store the result in optional object, and the type is integer, and let us say element equals. Alright, and optional provides APIs like is present, and then let's go ahead and let's call is present, and if element is present, then we are going to print the element. Okay, we are going to call get method to get the element from the optional object, and here if element is not present, then we just print the message like stream is empty like this. Okay, great. So this is how we use find first method to find first element from the stream. Now let us see how to use find any method to find any element from the stream. For that, what I will do, I will again convert list into stream like this, and then on top of stream I am going to call find any method and look at here, find any method returns optional describing some element of the stream, or any empty optional if the stream is empty. And here I will just check if the element is present, and then if the element is present, and then I will print the element, else I will say stream is empty. Okay, so let's go ahead and let's run the program. So look at here, the output in both the cases it returns the result is 1 1, because find first method returns the first element from the stream, and find any method it will just return any element of the stream. Okay, great. So this is how we use find first and find any method. Now let us say how to use count, min and max methods. Alright, so we use count method to count a number of elements in a stream, and we use min method to find a minimum element of the stream, and we use max method to find maximum element of the stream. Alright, let's go and let's quickly see how to use count, min and max methods. So look at here, this is the stream of integer elements, and I'm going to count a number of elements in this stream. So for that I'm going to just provide a sysout here, and this is the stream object, and here I'm just calling the count method. So this will count a number of elements in a stream. So let's go ahead and let's run the program. Look at here, the output printed 9 because there are 9 elements in the stream. Now let us see how to use a min and max methods. So here we have stream, and what I will do is I will just store integer here like this, and I'm going to call min method. And look at here, min method requires a comparator as a method argument. Alright, and here we are going to use a comparator dot comparing method, and comparing method requires a function interface. So for that what I will do is we'll just call the integer value of method here. Okay, and here what I will do, I will call get method because it returns optional, and this returns get method returns integer, and this is the minimum value of the stream. I'm just going to print here to the console like this. Alright, so similarly let's see how to use a max method. So I'm going to call max here, and again max requires comparator as method argument, and here what we will do, again we will use comparator, and we are going to use comparing method here, and similarly call the integer value of method. This returns optional, so let's get element by using get method. This will return an integer, so let's go ahead and let's store it in some integer. I'm going to say max, and what I will do, will just print the element to the console like this, max. It's pretty simple example. We are just using count method to count a number of elements in a stream, and min method to find minimum element of this stream according to the provided comparator, and we are using max method to return a maximum element of this stream according to the provided comparator. So let's go ahead and let's run the program, and look at here the output. Oops, it prints a stream bin already closed. Alright, okay, we need to create a separate stream for each operation. For that what I will do, I will just copy this and paste it here like this, so this should work. Let's go and let's run the program, and look at here the output. The count method returns 9, and min method returns 1, and max method returns 9. So this is how we use count, min and max methods. Alright, great. So Java 8 provides a new method, that is forEach method, to iterate the elements. It is defined in iterable and stream interfaces. For example, let me show you the internal implementation of iterable interface with forEach method, so that you will understand. So this is the iterable inbuilt interface, and it has a forEach method here. So alright, and if we look at the stream interface, so forEach method is also defined in a stream interface. Yeah, so look at here. Okay, and the iterable interface is extended by various collections. So the collection classes which extends a iterable interface can use this forEach method to loop the list or set or map, etc. So I'm going to show you how to use forEach method with list, set, map and stream with examples. Alright, so let us first see how to use forEach method with list. So let's go ahead and let's create a package here, and I'm going to give a name as forEach. Okay, alright, so let's go ahead and let's create a main method, and before that let's create a person class with name and age as attributes, private string name, private int age, and let's quickly create a constructor, and let's quickly create a getter setter methods to access these private fields. Great. Now what we'll do, we create a list of person objects, list of person, list new. We're going to array list here, and let's go ahead and let's add a few persons to person list. Add new person. Here I'm going to give name as Ramesh, age as 29, and let's add one more person dot add, and I'm going to add a new person here, and I'm going to name as Tony, and age is 50. Alright, let's copy this and let's add one more person, name it as a Tom, age 45. Let's add one more person, and person name is John and age is 55. Alright, so this is the list of person objects. Now what we will do, we will iterate over list using forEach method. So what I am going to demonstrate that without using forEach method, that is prior to Java 8 we were needs to use forEach loop, right? forEach loop or a normal for loop to iterate over a list. So without Lambda or Java 8 or prior to Java 8, we use a forEach loop to iterate over a list, right? For example, here how it looks like, and here we just print a person object. Okay, person dot get age. So this is usually we do prior to Java 8, that is by using forEach loop. Okay, so let me run this program. So here you can see. Alright, now let's use a Java 8 forEach method with Lambda expression to iterate over a list of elements. So how to do that? Let me show you. Here I am going to use a forEach method now. So look at here, forEach method internally uses consumer interface. So consumer interface is the function interface. It has a accept method. Okay, and here what we'll do, we'll pass a argument here, because consumer interface has accept method. It has a single parameter, so that we need to add here also a single parameter person, and let's provide a lambda expression syntax here, and here just give us this out, and let's print a person object, person dot get name, and sys out person dot get age. Alright, so this is how we use forEach method to iterate over a list. Okay, pretty simple, right? Now let us see how to use a forEach method with stream. Okay, so Java 8 provides a stream, right? So let us see how to use a forEach method with stream. So here I will provide a list dot, I will convert a list into stream first, and I am going to use forEach method here, and here I will do sys out and here I will just copy this and I will print here. That's it. Okay, so look at here, first we convert a list into stream, and stream has a forEach method, so we can use a forEach method of stream object to iterate over a stream. And let me run this. Yeah, here is the output. Okay, so this is how typically we use forEach method with list and stream. Okay, so let me show you how to use forEach method with a set. Okay, set of objects. So for that, quickly let me create a class and let me name it as set forEach example, and let's here I will create a main method, and let me just copy the list of persons and let me convert this into set of persons quickly. Okay, so now we have a set with few persons. Okay, set of persons. Now what we will do, we will use a forEach loop. We use forEach method to iterate over a set of persons. So how to do that? So let me rename this list with set so that you will understand. Now let's use, so before Java 8 we were supposed to use forEach loop, right? So let's go ahead and let's see how to use forEach loop to iterate over a set of persons. Person, here set, and here we provide sys out person dot get name, and here again we provide sys out person dot get age. Alright, so let's go ahead and let's run this program, and here is the output. Okay, and now we are going to use forEach method. Okay, so we are going to use forEach method plus lambda expression. Okay, set dot forEach, and here what we will do, we will just pass a single argument here, that is person, and here we are going to use a lambda expression, and inside that we are going to print a person object like this. And let's go ahead and let's run this program. Yeah, here we go, here is the output. It's pretty simple, right? So this is how we use forEach method to iterate over a set of person objects. Now let's see how to use a stream with forEach. So let's first convert a set into stream, and stream has forEach method, so we can use forEach method like this. Pretty simple, right? So this is using stream with forEach method. Great. So let's go ahead and let's run this program. Yeah, here is the output. So this is how we use forEach method to iterate over a set of objects and stream a stream of objects. Okay, now we'll see how to use forEach method to iterate over a map. Okay, so for that let me create a class again, here I say for map for each example. Okay, and let's quickly create a main method, and here let's create a map. Here I will give a ID here, and will provide key as integer, value as person object. Okay, and here what I will do, create a map with hash map. Okay, great. Now let's add a few elements to the map. Here let's use a put method, and I will add key as 1 and value as new person, and I'm going to give a name to the person Ramesh 29. Alright, so let's add a few more elements to the map. Here key 2, and here let's add a person, and let's name it as Tony, and let's give a age as 50, and let's add one more person, use put method, and key as 3, value as new person, and give name as John, and age as 55. Alright, so this is the map with key value pairs. Now let's see how to use forEach loop post. So prior to Java 8 we were supposed to use forEach loop, right? forEach loop to iterate over a map. So here you can see how we use entry, and the entry provides key value pair, right? So choose here key value pair, and here we pass an integer and value as person, entry, and here map dot get the entry set here. And now supposed to print a key here, entry dot get key, and we supposed to print here value, entry dot get value is the person, and we are going to print person name here. So let's go ahead and let's run this program, and let's see the output. Yeah, here we go. So look at here, we are printing a key and value is the person name. Okay, so this is how we use forEach loop to iterate over a map or to entry set. Okay, now let's go ahead and let's use a forEach method, okay, with a lambda expression. Okay, so map provides a forEach method, and here we need to pass a key value pair, right? So let's say key as k and value as v, and here what I will do, I'm going to use a lambda expression syntax here, and yeah, I'm going to print here a key is k, and again value is v dot get name. Pretty simple, right? Okay, let's go ahead and let's run the program. Yeah, here is the output. Okay, so this is how simply we use a forEach method to iterate over a map entry set. Okay, this looks good, right? So this is how we use a forEach method with a list, set, and map. So let me summarize the function, consumer, and predicate interfaces. So these are the function interfaces which takes single parameter. Okay, for example, function is a function interface, it has apply method, and it takes a single parameter and it returns a result. Okay, and similarly consumer is a function interface, it has accept method, it takes a single parameter and doesn't return anything. Similarly predicate is a function interface, it has a test method, it takes a single argument and it returns a boolean value. So if you look at these functional interfaces, so these interfaces takes a single parameter. All right, sometimes we have a requirement to pass two parameters to the interface. In that case, we can go for by function, by consumer, and by predicate functional interfaces. For example, by function is a functional interface. It has an apply method and it takes two parameters. Alright, so it is similar to function interface, but this method takes two arguments and returns the result. Alright, so similarly, by consumer is a functional interface. It has an accept method similar to consumer, but it takes two parameters. Alright, and by predicate is a functional interface. It has a test method similar to predicate, but it takes two parameters and returns a boolean value. So whenever you have a requirement to pass two parameters as a method argument, then you can go for these binary functions. Alright, so these functional interfaces are called binary functions because these functional interfaces takes two parameters. Alright, I hope you understood the differences between these functional interfaces and when to use these functional interfaces. Alright, so in this video we are going to learn a lot about by function, by consumer, and by predicate functional interfaces with lots of examples, and we are going to use a lambda expression to implement these functional interfaces. Alright, just watch this video till end. You will learn a lot about these functional interfaces and its use cases and when to use these functional interfaces and lot more things. Alright, let's get started. Let's begin with by function functional interface. By function functional interface is a built-in functional interface which is introduced in Java 8, and we can use a lambda expression to implement this functional interface. Okay, so look at here, by function is a generic interface. It has three parameters here. So first parameter is the type of the first argument, and second parameter is type of the second argument to the function, and this is the type of the result of the function. Okay, by function interface provides apply method, and this apply method takes two arguments. So this is the type of the first argument to the method, and this is the type of the second argument to the function, and this is the result of the method. Let's understand more about by function interface with an example. So let's quickly create a class and let's name it as by function demo. So let's begin with the traditional way. In a traditional way, we just implement an interface like this. This is the by function interface, and let's pass first argument type as an integer and second type argument as integer, and this is the result of the function. So let's also pass an integer here, and here quickly override apply method. So this is the first argument integer and this is the second argument. So let's add these two arguments, t plus u, and then this will return a sum of these two numbers. Okay, and here what we'll do, quickly create a main method and we create object of by function interface, and then we'll call the apply method like this. Alright, I'm going to just print the result here. So this is the by function object, and then call apply method and just pass 10 and 20. So 10 plus 20, it's a 30. So you can see the result is 30. Okay, so you can also pass different parameters here, 200 and 100, and let us run the program and look at here 30 and this is 300. This is the traditional way to implement by function interface, and we need to override a method like this and we provide the implementation. So let's go ahead and let's replace this traditional implementation with the lambda expression. So before that, what I will do, I will use anonymous implementation so that we can easily replace anonymous implementation with lambda expression. New, and then this is by function anonymous implementation, and here we need to override the apply method and we need to provide the logic here. Okay, so let's remove this because we are using anonymous implementation of by function interface here. Okay, so this is the anonymous class which implements by function interface. So let's run the program and look at the output here. Now it's easy for us to replace this anonymous implementation with a lambda expression. As we know that lambda expression is an anonymous function which don't have any name. So let's go ahead and let's replace this a name here, and here what we need to do is here we need to provide an arrow. So this is the syntax of lambda expression. Okay, so look at here, this is the lambda expression. Now even we make this lambda expression shorter, so let's replace this types here, because compiler will know the type of the method. And here we can also remove the open and curly braces, because this has only one statement. Look at here the lambda expression. In a single line we can do the stuff, right, like this. So let's run the program again. So look at here the output. Okay, so this is how we use by function interface. So whenever you have two arguments and you want to perform some operation on two arguments and you want to return something, then you can use a by function interface. Alright, so similarly you can do for subtraction, multiplication and division. For example, here I can simply copy this lambda expression and I can name as subtraction, something like this, and t minus u, and here I'm going to just call this subtraction method here, and here I will pass 200 minus 100 like this. So let me run the program again. So look at here, 200 minus 100, it is 100. So similarly let's do it for multiplication. And here let me just copy this line of code, and here what we'll do, we'll call multiplication dot apply method. So this will multiply 200 and 100. So look at here, here we need to provide multiplication operator, and look at here the result 20,000. Similarly let's do it for division. So this is the division. Alright, and here we can just copy this statement, and here we can replace multiplication with the division like this. Let's run the program, and here is the output. Okay, so this is how we can use by function functional interface to perform operation on two arguments. Okay, it's pretty simple, right? So what we can do, we can chain the functional interface like this. So let me quickly create a function interface object here. So this will take one argument, let us say number, and this simply multiply number into number. Okay, so what we'll do, we'll first by function and then we call and then. So we first get the sum of two numbers and then we pass that number to this function object, and then what we will do, we will multiply these two numbers. So here I will pass 10 and 20. Okay, so basically what it does, it will call this by function and then it will sum these two numbers, and the sum is again passed to this function, and this function will multiply the sum twice. Okay, and then we store result in some integer like this, and finally we print the integer. It's pretty simple, right? So let's go and let's see the output. It's 900, right? So sum is 10 plus 20, 30. 30 into 30, it's 900. Okay, so this is how we can use and then method to chain the function object. It's pretty simple, right? So one more example, we can say we can pass a list 1 and list 2 as two arguments, and then we can combine these two lists and we can get as a result. Okay, so this is how we use a by function functional interface. So look at here the name by, it means that we need to pass two arguments and we get a result. Alright, I hope you understood the usage of by function functional interface. As we know that functional interface is an interface which has only one abstract method, and we can use a Lambda expression to implement a functional interface. Okay, and by consumer is a built-in functional interface which is introduced in Java 8, and we use a Lambda expression to implement by consumer functional interface. Alright, by consumer functional interface is similar to consumer interface, except it takes two arguments. Okay, so consumer functional interface takes single argument, and by consumer functional interface takes two argument. Okay, and by consumer interface provides a method called accept. So this accept method takes two arguments and it returns nothing. Okay, look at here, the return type is void. So basically we use by consumer functional interface whenever we want to print or we want to perform some operation on these two arguments, and we don't want to return anything. Okay, in this case we can use this by consumer functional interface. So it basically consumes these two arguments and it doesn't return anything. So it is similar to consumer functional interface. So in case of consumer interface, we use accept method with a single argument and we consume this argument and we don't return anything. If you want to know more about consumer functional interface, then you can visit my previous video tutorial. Let's understand more about by consumer functional interface with an example. So let's quickly create a class and let's name it as by consumer demo, and it has a main method. So select main method here. So let's begin with the very basic. So first let us see the traditional way implementation of by consumer functional interface. So let's take an integer here, post argument, and second argument also integer. Let's override the method. So you need to override accept method here, and what we'll do, we'll just print the sum of two numbers. Okay, so I'm going to just rename this a and it's b. So let us say a plus b. Okay, now what we'll do, in a main method we'll need to create object of and let's run the program and let's see the output. The result is 30. 10 plus 20, 30. Okay, so we are basically passing two integers and we are just adding these two integers and we are printing the result here. So whenever you want to take two objects as an input and you want to perform some operation on it and you don't want to return anything, then you can use by consumer functional interface. Alright, so this is the traditional way implementation of by consumer functional interface. So let's go ahead and let's see how to use Lambda expression. Okay, so what we'll do here is first we'll use anonymous implementation of by consumer interface quickly, and then we'll replace it using Lambda expression. So it's pretty simple. So let's remove this part. Okay, so this is the, here we need to call accept method. I am going to pass 10 and 20, and this is a and this is b. So this is the anonymous implementation of by consumer interface. Let's go and let's run the program and look at here the result. Now it's easy for us to replace this anonymous implementation with a Lambda expression. As we know that Lambda expression is a anonymous function which don't have any name. So let's go and let's remove this part and let's provide an arrow here. This is the syntax of Lambda expression. So this is the Lambda expression. Even we make it shorter because this body, Lambda expression body, has only one statement. So what we can do is we can remove the open and curly braces like this, and we can also remove the type here. So this is the Lambda expression to to add two numbers and print the result. So let's run the program and let's see the output. Yeah, here we go. It's pretty simple, right? So similarly we can do it for other operations like subtraction, multiplication and division. So here I'm going to name it as subtraction, a minus b, and here what I will do, I will simply call accept method, and this is 20 minus 10. So let's run the program, and here you can see the output 20 minus 10 10. Okay, similarly let's see the other operations. Multiplication, and here we need to change the logic. Okay, and here multiplication dot accept, pass 10 and 50. Okay, so this will give a result as 500. So similarly let's do it for division. So let's change the name here, division, and change the logic. Now let's call accept method, 20 divided by 10. So this gives 2 as a result. Okay, so this is how we use by consumer function interface. It takes 2 arguments and it doesn't return anything, but it will does some operation on these 2 arguments. For example, here we are doing addition, multiplication, subtraction and division. So this is a very simple example to demonstrate how to use by consumer function interface. Now let us see how to use by consumer interface with forEach method in map interface. So let's go ahead and let's create a map here. So this is the map, and here are few entries in a map. So this is the entry for Java, C++, JavaScript, Go and other entries. Now what we'll do, we'll use a forEach method to print key and value of this map. Okay, let's go ahead and let's use forEach. So look at here, forEach method takes by consumer functional interface as a method argument. Okay, so look at here, this is how we use by consumer in a forEach method. So what here we need to do is we need to implement a by consumer interface using Lambda expression. So by consumer interface takes 2 arguments, let us say k and v. K stands for key and v stands for value, and then this is the Lambda expression syntax, and here we need to provide open and curly braces. Okay, and then we need to just print k and here value. What is the error here? Yeah, we need to close the brace right here. Alright, so look at here, we are just printing key and value from the map. So this is very important. So look at here, forEach method internally takes by consumer function interface, and by consumer interface takes 2 arguments, key and value, and then we are just printing this key value here. So this is how we use by consumer function interface with map, and we have also understood how to use by consumer function interface to perform different operations on 2 arguments. Okay, and it doesn't return anything. By predicate is a built-in function interface introduced in Java 8, and this interface takes 2 arguments. Look at here, t is a type of the first argument to the predicate, and u is the type of the second argument to the predicate, and it returns a boolean. So for example, by predicate interface provides a test method, and this test method takes 2 arguments and it returns a boolean result. Okay, you can use by predicate function interface whenever you want to compare 2 objects or 2 strings and you want to return the result as boolean. Alright, so by predicate function interface is similar to predicate function interface that we have discussed in previous video, but by predicate function interface takes 2 arguments and predicate function interface takes single argument. Alright, if you want to know more about predicate function interface, then you can visit my previous video tutorial. So just remember, by predicate function interface provides test method. It takes 2 arguments and it returns a boolean value, either true or false. Okay, So let's understand more about by predicate function interface with an example. So let's quickly create a class and let's name it as by predicate demo, and let's quickly create a main method. So let's start with the very basic, like first we'll see the traditional implementation of by predicate function interface. Here what we'll do, we will pass the string. So this is the example to compare two strings, and we return the boolean value. If both the strings are equal, then we return the true, otherwise false. Okay, and by predicate function interface provides a test method. Here we need to override it, and here what we'll do, we'll just compare. Here I will rename this s1 and s2, and here I will just compare these two strings by using equals method. s1 equals s2, so this returns true if both strings are equal, that is the content of both the strings are equal. So here in a main method I will create an object of this interface by predicate equals to new, and then we are creating basically object of by predicate demo class here, and we need to call the method. So here we call the test method, and here I will pass first argument as Ramesh and second argument as Ramesh, and again one more, we can do one more test here. So I'm going to pass here Java guides, and here I will pass Java guides. So look at here the case, so this is the small letter and this is caps. Okay, so let's go and let's run the program, and look at here the post statement we have tested, it is a true and this is the false. So this is the traditional way implementation of by predicate function interface. Now let's go ahead and let's use Lambda expression. Okay, so what I will do, I will first use anonymous implementation, and then we'll replace anonymous implementation with the Lambda expression. It's pretty simple. So we need to just replace the logic here, that's it. And here we no need to implement this interface, and we no need to override the method here because we are already implemented this interface using anonymous class. So let's go and let's run the program. Look at here the output. Now it's easy for us to replace this anonymous class with the Lambda expression. So as we know that Lambda expression don't have any name, so let's go and let's remove this part. So look at here how I am constructing a Lambda expression. So let's provide an arrow here. This is the syntax for Lambda expression. So look at here, this is the Lambda expression. Now even we can make this Lambda expression shorter. So this Lambda expression has only one statement. Let's go and let's remove the open and curly braces as well. Okay, and we can also remove the type here because compiler will automatically recognize the type based on the method argument type. Okay, so that's it. So look at here the Lambda expression, it looks neat and concise, right? So let's run the program and look at here the output. So this is how we use a by predicate function interface to compare two strings and return a boolean value. Okay. Similar to predicate function interface, by predicate function interface also provides methods like and, negate, and or to check multiple conditions. Alright, we can check and condition, or condition, and negate condition. So let's go ahead and let's see. Let's go and let's create example to use and or methods. Okay, so for that what we'll do, we'll create a predicate implementation. Let's pass a post argument as integer and second argument also as integer. Okay, and here what we'll do, we'll create a predicate 2, create a Lambda expression x, y. So these are the two parameters. So what I will do here is I will just add a condition x greater than y, something like this. Okay, and similarly let me copy this and let me create one more condition here. Let me give a name as by predicate 3, and let us say this is x equal to y. Okay, so these are the two conditions. Now let's go ahead and let's see how to use and or method. Okay, here I will call and method, and then this is 3, and then here I will call test, and I will pass 20 and 10. Okay, so let's take the result in a boolean. I am going to call it as result. Okay, and let's print the result to the console. Okay, so here by predicate true, so this is the condition. It says x greater than y. Here we are passing two arguments, 20 greater than 10, so this is true. And this condition is x equal to y, so 20 equal to 10, so this is false, so this should be a false. Result should be false. So look at here, result is false. Now let us see how to use or condition. Okay, so similarly let me quickly copy this, and let's use or condition here instead of and here say result 1. Okay, so this condition is true and this condition is false, and this is true or false. It means that this should be a true. So look at here, this is logical or, this does logical or condition, and this does logical and condition. So look at here, the output, it's true. Okay, so this is how we use and or method. Okay, so this is how we use by predicate function interface. So whenever you want to compare two objects and you want to return as a boolean, then you can use by predicate function interface. So look at here, the by, so it means that it takes two argument and it returns a boolean result. Okay, it is similar to predicate function interface, but it takes two argument. Alright, so this is all about by predicate function interface. I hope you understood how to use by predicate function interface.